and the
I can
distance.
change the amount of mass that I'm using,
well, then that's
and it will
the
make
cause,
the force increase.
not gravity.
It's true.
Then
Paige's
that's
not
the
understanding
cause, more
you.
mass,
Let me help
not
you.
gravity.
Yeah. So if I
Yeah,
change
you're
the
not-
amount of mass, how is that not?
You've changed the electrostatic potential of that item. Look at the bloody what's it called? The piece of paper where you've got all the elements. What's that thing called? You know, where you tell you what all the different elements are on that piece of paper. They're all coloured.
Periodic table.
Thank you. Look at that. It will even tell you on that according to the density of each thing, it has a different potential, different electrostatic potential. You know, the electric forces for the first few thousand miles from the ground up, that's all that matters, are these electric forces.
No.
I completely
Few
disagree with
thousand
you.
miles, they say.
Yeah, Paige,
I
when you
think
add...
what Paige's... Hold on, let me say something real quick.
Well, no, I'm going to respond to what you said.
I know, let me just try to help, Coach.
No, let Kosho respond.
James,
She doesn't need help.
Can...
For fuck's sake, she doesn't need help.
Neither of us need.
Yeah, Paige is fine. Go ahead, Paige and Kosho.
Well, yeah, you said that you can manipulate it by, adding more of it in there, and that's going to create a stronger force. I'm saying that too. I can do the exact same thing. I can add more mass to an object and change the amount of force that's acting on it.
Yeah, but the problem is, Kosho, I'm saying that mass that you're adding, because of the amount of electric potential in each atom, when you add more mass, you're actually changing the electrostatics of that object and not actually manipulating anything about gravity at all. You know, you need to get gravity, separate gravity from everything else. Like I can separate electrostatics and I can add potential to something, knowing exactly how much I'm adding, all that kind of stuff, and force it to go in a different direction. I'd like to see you guys do the same thing with gravity.
I got you. I
Actually manipulate gravity.
I understand you saying that. I can do the same thing, but successfully. I can add more matter. I can add more mass. Hold on, Paige. I can add more mass, having different electrostatic potentials. So some mass that has one electrostatic potential and another mass that has a completely different electrostatic potential, I can use and add the exact amount of mass, and I can make this force increase, and I can do it at the rate at which the mass is increasing, and not at all at the rate at which the electrostatic potential is increasing. And I can show this and measure this.
Rubbish. Yeah. Show it then. Because I'm going to call absolute bull on that, Kosho. It will line up with the electrostatics, the 100 volts per however many meters it is when you go up in the air. It will match that. The gradient of the electrostatics is what causes this flow that is going.
It's 100 volts per meter.
From sky to ground.
100 volts per meter.
Why weren't we taught this in chemistry?
Yeah, why weren't you? Exactly.
Yeah.
Why
it's not a thing.
Weren't you? All on the periodic table. It gives you everything you need.
We studied electromagnetism, how it relates to chemical reactions, but nothing to do with weight.
We're not doing chemical reactions.
That's what
this is the
play.
Sorry?
That's where electrostatics come into play.
Well, sorry, with the density, you increase the density, you put more stuff in something, you're giving it more potential, whatever that atom is made out of, whatever its potential is, well, then you're just adding more of that potential. So you're not manipulating gravity at all. You're just putting more mass.
You said that. Yeah, the problem is that objects that have the same mass and two totally different electrostatic potentials, you can see that the electrostatic potential is not at all
and they fall at a different rate.
No.
You put something, you drop that thing through a copper pipe and it will fall slower than if you don't, because of the potential inside that copper, the different things reacting with each other.
So you're saying that,
but you're wrong.
You're saying that
These things do fall at a different rate.
You're saying that a very heavy ball and a light feather have the same electrostatic potential?
No, look at the periodic table. Everything has its own value.
Why do they fall at the same rate?
They don't. I just said that to you.
Why is it that when people do it, they fall at the same rate?
They don't. We've shown it. We had a demonstration where we had all these different elements. They all got dropped at the same time. They all fell at different rates. There's been balls dropped with magnets inside, where they've weighed them, made sure they're exactly the same weight, dropped them, and they drop at a different rate. It is all to do with whatever magnets, whatever electrostatic potential is in the thing, whatever the thing's made out of. Matter that it's made out of.
I agree. If you put magnets in something, you're gonna make it do something different than everything else. But every other example that everybody else has done, you put objects in a vacuum.
The elements, no. Oh, vacuum. Okay. Yeah. Look, even the ones with just the elements, they were just the same size bit, of stuff. They're just all different, and they all got dropped at the same time, and they all dropped at different rates. So it's just a fallacy for you guys to keep saying things fall at the same rate, because they don't.
I've seen that one example from Spurs Chemo 3 years ago, and that's the only example of that happening, right? But in every other example, you see things fall at the exact same rate.
I've
even got an example of the sun changing angular size daily and yearly, but you guys won't accept that either, because we are the only ones that have done this. I'm just saying that because this is so new, the things that we're thinking about testing, seeing if things can fall faster or slower depending on what you do to them, these things haven't been really looked at like this before. So, of course, it's only going to be a new thing. There's fucking two suns in the sky. Like, we've got film of two suns being seen. Like,
it's not about... Paige, it's not about it doing something new. It's about people have done this. No, it's not, because people have done this before. And people who do this every time, they see that objects that are a very light, small object and a very big, heavy object that have totally different electrostatic potentials, they're going to fall at the same rate.
They don't. They don't fall at the same rate. You drop
the only time you'll get anything,
and that hammer is going to hit the ground before that feather does. I'm sorry.
Not in a vacuum.
We don't live.
So
in
if you do this, so the only medium that this can be done in is in a vacuum.
They have to put us. Yeah, they have to put us somewhere that is not analogous to where we live to get there.
Yeah, it's totally.
No,
guys, don't be fooled by the vacuum bullshit. The vacuum is just less atmosphere. It's still atmosphere.
Yeah, guess what? And when you do the same test in the atmosphere,
don't be fooled by the vacuum bullshit.
When you do the same test in the atmosphere, and you have an object that's very large.
Nobody here knows what happens in a vacuum.
You're wrong.
You have an object that's very large.
How do you get a vacuum?
You have an object that's very large and big,
and they don't
and it has a lot of electrostatic potential, and you have an object that's small and thin, like a javelin, and has no electrostatic potential. That the electrostatic potential will have nothing to do with the rate at which they fall. It'll be the drag acting on them, because they're going to be different surface areas.
Where does one?
You can't just.
How does somebody get a vacuum? How does somebody acquire a vacuum?
You have to look that up.
They need a container first.
Of course.
Yeah, you need a container. It's a man-made tool. It doesn't happen in nature. And you're trying to say it's reality.
Need to be in one. Yeah.
There's nothing wrong.
So if you this is all I'm going to say real quick.
There's nothing
if you do these experiments in air,
James, there's nothing wrong with testing things.
No, nothing wrong with testing things.
Using man-made objects.
That's right.
I agree with that. Let me finish. If you do these experiments,
make it analogous to whatever you're doing.
Yeah, okay, let's not talk about a vacuum chamber then, okay? Because like I said, you don't have to use a vacuum chamber. You can use objects outside a vacuum chamber. They have totally different sizes and shapes. Totally different sizes and shapes, and you're going to find out that they fall at the same rate. Once you add in the drag. So the drag is going to cause them to go at different rates depending on their the surface area acting on them and their weight. But the actual
how about they might be a little bit wrong with how much they're attributing to drag. They might have that a little bit wrong, and what they're attributing to drag, maybe half of it could be attributed to this instead.
No, but that's where can't be true, because when you use those same objects in a vacuum, they fall at exactly the same rate. So that the only difference is that when one they're in a medium, and then in one they're in the medium. Hold on. In one situation they're in the medium, and in the other situation, hold on.
Fall at the same rate. That is wrong.
Yeah, they actually do. Paige. I know you keep saying they don't for some reason, but almost everybody will tell you that they do, and the people who tell you that they don't are just lying. That's just the truth. They fall at the same rate in a vacuum chamber.
Like when NASA
you're lying,
did the one feather and something else, and they dropped it, and then it changed to a group of feathers in the middle of it falling. Yeah, like those kind of liars.
Paige, I've seen this done. People have seen this done in
let me
classrooms. They show it to everybody.
You guys are blowing off on all these things
that don't fall at the same rate. So what you've seen and what I've seen are completely different.
Look, if you drop a basketball from your chest height in the medium of air, the result will be dramatically different by dropping it 10,000 feet high in the same medium with the same variable.
Well, of course it will.
Okay,
No,
so tell me
why
the
would
different.
it?
Tell
If
me
they're all
the
the same
10,000. Tell me the
If they're all the same
10,000,
variables, why
100,000
would it be
feet.
different?
Because it's a
Hold on,
dynamic,
man. I'm asking.
dynamic
Geez,
situation
dude,
where the object is
you guys
speeding up, increasing the drag. So
look at that. I'm in the middle of talking, and two people start talking, and then I'm the one that's told to be quiet when I do it, and you wonder why I do
Go ahead,
do
James. Okay, go ahead. Go ahead.
All right. So if you're going to claim that things fall at the same rate in a vacuum, I would agree if that's true. I would say, okay, that's true. But you can't just drop it at chest height or whatever their tallest vacuum is. You got to keep going up and up and up the same way you would do it in air. You'll get a different result.
People were interrupting is because you're saying the same thing very slowly. Okay, I get it.
Yeah, but what I'm getting at is, as you do these experiments,
go up in the air, and then the only reason that's different, the only reason you get a different effect is because drag is a product of the speed
is changing the result.
When something is speeding up as it's accelerating, which is what acceleration does to an object. It's going to speed up, which is going to change the drag, which is going to allow it to reach terminal velocity eventually. So the whole time,
yes, and I agree with all that. That's why I said if it actually did happen, that I would agree with it, because I'm picturing that actually happening. No matter how high you go in a vacuum, you'll get the same result. But you got to do the test, the experiment, in order to conclusively say that. But I'll digress from that. What I'm getting at is, if you do this exact same experiment you're doing in a vacuum, and you do it in air, you do it in water, you do it in mercury, you do it in a whole bunch of different mediums, the medium is going to give you a different result.
Listen, bro, you said you do it in a vacuum and you do it in air. A vacuum is air.
So that's what I'm, listen to me. So the air, you can vary, you can observe it, isolate it, vary, manipulate it, and control it. The water, you can observe it, vary it, manipulate it, isolate it, control it. In all these experiments, you can do all this. And then you want to insert something called gravity, in which you cannot observe, isolate, vary, manipulate, or control it.
Okay, to the person that said the vacuum is not air.
You just say the Earth is too big. You say the Earth is too big that it's within the experiment, so you can't take it out.
Yo, who's the idiot that said vacuum is not air?
I didn't say that at all. I didn't say anything about the Earth being too big. What I said was
no, but you'll get it's a medium, and you'll get
let him say. James, let him respond, please.
Yeah, what I said was, what I'll say again to you is that you can manipulate, isolate, and do all these things to what the cause of what you're saying it is, which is the mass. We say the mass is creating this effect, and so the mass itself can be manipulated, and the distance from another object can be manipulated, and you can see that this effect changes.
Well, then don't ever bring up gravity again, because you've done nothing with gravity.
What has more mass, a tennis ball or a beach ball?
That has nothing to do with Einstein.
It's Einstein's gravity too.
No, that's Newton's gravity with the mass attracting the mass. Einstein.
No, I didn't say anything about mass attracting mass. I said the mass is the cause.
You have to think about things from our perspective for a sec. Like, you know, if you just thought about what happens here on Earth without any orbits out in space and all this kind of shit, you don't need anything more than these electrostatic forces. Like they already admit they're way stronger. Like gravity, they don't even take gravity into consideration until they're thousands of miles out.
No, they take what? What are you talking about? No, they thousands of miles out.
Yeah.
No. So
yeah.
No, Paige. I don't know why you said that, but regardless,
posted the lecture on electrostatics at one of the big, American colleges or universities.
Is that the Feynman lectures? Is that the Feynman lectures on QED, quantum electrodynamics?
Yeah. What you're probably misunderstanding is that the gravity is not taking into account.
He actually says the electrostatic forces rule here on Earth. That they don't even.
Paige. That doesn't address.
You just said I was
last
wrong.
time I refuted you about this.
What I said.
That's quantum, isn't it?
It doesn't come into effect until thousands of miles or something like that. There's nothing about miles.
That's what he says.
Yeah. Well, Paige, gravity doesn't come into effect. They don't use it when you're talking about on scales smaller than an atom. Okay, this is when they don't talk about gravity. It's because there's other forces that are much more powerful at those scales than gravity will not be relevant at those scales, Paige. But a scale's larger than that. Scales at which we live in.
And he also goes
you have to include gravity, otherwise you get the wrong answers, Paige.
He goes on to say that you don't all you need to do here is these sums with these electric forces. That gravity has no, you're equating orbits and shit out in space with things dropping here on Earth. And they're two totally different things.
No, I'm not talking about space, Paige. Paige, you were the one who brought things up and then strawmanning me. I didn't say anything about space.
You want to make gravity into something that makes things drop here on Earth.
Paige, I didn't say anything about space when I gave the proof for gravity. I didn't say anything about space. I said I said you can manipulate the mass. Paige.
When you're here
I said you can manipulate the mass, Paige. That's what I said. And Richard Feynman, the guy you're reading from, is a physicist, a quantum physicist. He's not talking about things on our scale. He's talking about things in quantum mechanics, which is things of the atomic scale. Okay? That's where that's relevant.
No,
it's not relevant. He's not saying gravity's not relevant. He's saying it's not relevant at that scale.
And what scale are we talking about, Kosho?
The quantum scale. He's a quantum physicist.
Are we talking about Earth scale or universe scale?
Universe scale, gravity is indeed relevant.
So there's enough quotes in that
page of microscopic, yes.
There's enough quotes in that Feynman lecture to ruin the globe.
We don't need any of this bendy space-time gravity here on Earth because... And you're just going to jump in to say, you're wrong, Paige, and just, that's it.
Well, you know what? Yeah, we do deal with gravity.
I hear you say that 50 million times a day, so, put some oomph behind what you say.
I want you to isolate, vary, manipulate, control gravity. Do it in an experiment.
I can do that with electrostatics and make something go the other way.
The cause of gravity.
I can do it.
You gotta manipulate the
thing. Except for we come with the right answers.
No, you can't.
Yes, you can manipulate
determine the cause of the effect. You got to be able to manipulate the cause.
Exactly, you can manipulate the cause of gravity.
To make sure it's causing the effect.
That's right.
So
that's what I'm talking about. You can change the size. You can change the amount of mass. You can change the distance. This manipulates the mass, changes the effect.
Mass, which changes the amount of electric potential, which changes what the thing does. Thank you very much, Kosho. Nothing to do with gravity. You didn't manipulate gravity. You didn't bring gravity even into the sentence. Thank you very much.
Electromagnetism has nothing to do with Cavendish.
Cavendish is ridiculous. If you're still going off Cavendish, dude, just leave.
Don't you find it odd?
Get out of here.
When measuring the amount of force acting on something, falling down, like something like a ball being dropped onto something, to measure the force, you will not put anywhere in there the electrostatic potential. What you'll put in there is the acceleration, which we know, and the mass of the object itself.
Yeah, but now
and the mass of the object itself. Paige, hold up, Paige. Paige, hold on. I'm making a point, and you're going to argue some other point.
Paige, let him finish. Let him finish.
Yeah, the force that's acting downwards is going to be due to the acceleration that we know and the mass of that object. And this will get the right answer every single time. the electrostatic potential will not need to be calculated into it. And if you did that instead, you would get the wrong answer almost every time.
I agree with what he's saying.
And when did you do this to check? When did you do this to check, Kosho? Show me your math. Show me all your equations.
You're doing the exact thing. Hold on. He's doing the exact thing with gravity that he just claimed you're doing.
James.
So can you please show me your workings? Show me your workings for this math, please, Kosho.
You need to see. You need me to show you the mathematics for calculating the force of a falling object.
Where you yourself calculated the same object falling and did one with gravity and one with electrostatics and show how the electrostatic one math was wrong.
James,
assertion that you've done.
Redo a test right now.
Hold on, Kosho. James, when Paige is done, you're next.
No, you're making a claim that this is the truth. So I'm assuming you've tested it and done the math. I'm asking to see it.
Yeah, in order to provide what you're asking for now, I would need to stop what I'm doing and do this experiment and record it and write it down. This is not. This is something that doesn't need to be argued, Paige.
So you have.
It's not Paige. It's not Paige. It's not in contention, Paige. It's not in contention, Paige. It's not Paige. It's not in contention. What the force of a falling object is, Paige.
It is.
No, it's not.
It is in contention.
It's not.
It is.
Paige, you're mad.
That's why we're here.
You're mad, Paige.
I've
Seriously.
got a smile on my face, darling.
I'm not talking about that kind of mad, Paige. I'm talking about if you think that the object of something falling, the force of the object falling is not going to
manipulate my cause and make it go the opposite way.
Acceleration.
Can you?
And you're crazy.
Hold on, guys.
Do a proper scientific experiment, manipulate my cause and make it go in the opposite direction. Can you do that?
I told you yes.
Let him respond. Let him respond.
Yep. I've already showed you that we could.
He said he's already shown you, Paige.
Posted it 16 times.
Pathetic. He's not manipulating his cause. He's saying mass. He changes his mass. Well, then mass is the cause, not gravity.
That's right. Mass is the cause.
Not the bending of space.
Thank you.
Mass is what
mass has electrostatic potential. Yes. You can look it up on your little periodic table there, Kosho. Go and check that out.
I got a question on mass. Is that all right?
Go ahead, James. Go ahead. Sorry.
If you have a steel ball bearing the size of a tennis ball, let's say it weighs 20 pounds. It's the size of a tennis ball. What has more mass, that or a beach ball?
Likely a tennis ball.
The steel ball bearing? So the smaller one.
Yeah, depending on the beach ball, yeah. If one is heavier, it's going to...
Right, because, they're telling us that there's gas giants out there. And they got more mass than the Earth. Oh, man. They would have to be like... Right, man. I know, but I'm getting somewhere with this. They'd have to be like beyond the size that they're telling us to have the mass of the Earth, which is rock, iron, and all the steel that I'm talking about. The ball bearing. Right? So you could actually have smaller planets out there with more mass than larger ones orbiting it. Would that be correct?
Yeah, if it's a black...
In this...
what are you saying? You're saying a small mass? If you have a small volume and a large amount of mass, you're going to create a vacuum. I mean, you're going to create a black hole. I'm sorry.
What I'm getting at is your definition of mass is density. Because mass the beach ball... Hold on. Let me finish. The beach ball is more massive. It takes up more room than the steel ball bearing. But the steel ball bearing weighs more. That's just its density.
Speaking faster.
Not its mass.
It's like I like you pick pauses in between every word. Wait, why
do people use mass?
I don't want you to explain yourself. They really don't. The density of an object is simply the mass divided by the volume. You need both those properties to determine its density. So just because something's bigger is not going to automatically tell you that it's more.
No, you need the variable.
It's not going to automatically tell you it's more.
You need the variable.
James, let him respond. James, let him respond.
And then you come up with a value. If the value is bigger than the other value, there's going to be more density or less dense. You have to have both the mass and the volume.
No. What you just said was volume. That means the beach ball.
Jesus fucking Christ! I said it as clearly as fucking day. I'm about to call. I swear to God, dude. You guys are smarter than this.
It's okay.
You guys are smarter than this.
Hold on a second.
The mass and the volume. The mass and the volume. Not one thing.
Okay.
And I would have thought you'd be smart enough to realize that you are not manipulating the cause of your effect, Kosho.
Oh, Paige, hold on. What has more volume?
Let James go back.
The beach ball or the ball bearing? What has more volume? The beach ball
has more volume. So if you're asking which one has more volume, the beach ball has more volume. If you asked if that means that it has more
which one has more mass?
No.
So your definition of mass, whenever I hear you, Kosho, say mass, you're talking density. And it's not the volume, right? It's actually what it's made of.
Okay, do you have a pen and paper?
Because you could have something.
You're going to write this down. Okay. The mass is the amount of matter. Okay? It could be any shape.
Oh, you didn't say that before.
You can have water.
Let him finish, James. James, let him finish.
Water can be all over the floor.
Type of matter.
It's not going to be in one place. Okay? That's the amount of mass. It doesn't matter how big the container is. It's just the amount of mass is the amount of matter that takes up any given volume. It could be tiny, it could be big, it could be spread out. Okay? The volume is the amount of space that it's taking up. Okay? These are two different properties. Now, when you combine them, you take the amount of matter, you divide it by the amount of space it's taking up, and that's what gives you the density. These are three totally different properties. One is dependent on the other two.
Hey, can I ask a question? Oh, you got a follow-up, James?
Yeah, so your definition of mass, like I said, is density.
That's right.
Density of the object. Why use mass?
You caught me.
When it's undefined. Density is defined. Why use mass? That's where I was going.
Hey,
you guys, but it's frustrating.
Yeah, well, I got frustrated earlier too. Like Howard, I wanted to ask you, why did you say that a vacuum isn't a medium?
Well, practically speaking, it is not a medium. You're evacuating the contents of that space. So, for practical purposes, it's not. Do I?
Okay.
I think percentage cough.
But
go ahead, Left Lane.
What is the distinction there, though, Howard?
It's the amount of matter that's in the space.
When we're talking about the density disequilibrium between an object and the medium it's in, don't you think that a vacuum would be considered a density within that definition, or a medium within that definition?
No.
Why?
Not to me, it's not.
Why?
Because there's not a significant amount of matter in there to necessarily consider it a medium.
All right.
If you were in a vacuum, you would die. I mean, there's nothing there.
Well, let me ask you this then. Okay, so I got a vacuum chamber. I add 1 molecule of oxygen. Is it a medium now?
No. Like I said, it's a matter of practicality, and no such thing as a perfect vacuum.
10 molecules, 100, 1,000, 100,000, a million, a billion. How many molecules?
He said you would die in it. So basically, you have to be able to breathe in it. And if you can't breathe, then it's a vacuum and not a medium. And if you can breathe,
so if you
then
can't,
it's air.
If you can't breathe in it, then it's not considered a medium.
Yeah, y'all are being pedantic.
No, you're being pedantic, sir.
That's literally what you said.
With that medium, with that guys, water is a medium, and obviously you can't really breathe in water. So let's not denote it as something that is unbreathable therein, right? Let's outline first what a medium is, and let's not play semantical games in order that we can move forward this actual whole conversation. Okay? So what would we all consider a medium, right? A medium being, let's say, right, so obviously when we say that second law of thermodynamics, when we're talking about space, for instance, right, we have people talking the semantics of that. We would just say a medium would be something in which space is in space, right? So not just space is in the actual space that we talk about is up there. We're talking about depth, width, and breadth, right? An area of depth, width, and breadth that has something in it that clearly denotes it to be something like that, but also isn't a privation therein of, let's say, gas, light,
That's a terrible definition, bro.
Yeah.
Right.
But no, I get what you're saying though. Like, yeah, it's what is in what
I would say a volume in which something can propagate.
A volume that things can go into.
A volume in which something can propagate.
Yeah, there you go.
Well, no, that would be
there
a volume.
we go.
No, so this is the best way to think about it. Because this is the best way to think about the vacuum. Because left lane's not entirely wrong, but it's also semantical. Because a medium is to a vacuum as a quantity is to zero. And that is to say that zero can be considered a quantity, but really it's the lack of having a quantity. So it's not really what he's saying is not wrong, but it's also it certainly isn't a medium. A vacuum would not be a medium, but you can describe a vacuum. You can describe the medium of a vacuum. If that makes sense.
What?
Because you can describe a number that's very close to zero, but it's not exactly like if it's not exactly zero, it's not exactly zero. But if it has if it's negligible value, then it basically is zero.
So how many molecules do I need to have inside the volume before it's a medium, Kosho?
Said you can describe it as a medium.
Okay.
I just said.
Okay, I got you. All right, fair enough.
Yeah, but it's not, a vacuum itself is not a medium. It's not what's described as a medium. The medium can be described by saying there's next to nothing in there, which is basically.
Yeah. So how many gas molecules does he need in order for it to be considered a medium?
Just answer that, man. If there's nothing there at all, if there's nothing at all that's there, then it's not a medium. If there is a very few particles, because it's a very near vacuum, the medium you could say that you can describe the medium as being a near vacuum.
So one
molecule. You would technically be correct to say it's a near vacuum, but it's never going to be perfect vacuum.
But everybody says that.
But what's the actual argument? Why are we talking about this?
They're trying to confound a vacuum that we have, which is not a perfect vacuum, into a perfect vacuum by saying that whatever's in it is negligible, so it's not a medium. If it's not a medium, it's a perfect vacuum.
Relative density is what causes the force. That's what's being described.
Yeah, and they think just because you're in a vacuum, something weird would happen.
You mean the force that I call the justification for the violation of the first law? Is that force?
Oh, yeah.
Because I brought my buddy Crack in here to kind of.
He asked what the whole point of the conversation was. I was letting him know it was about relative density being the force and not gravity.
Why don't you introduce your
asking about
Elijah? Why don't you introduce your friend Crack Villain?
Well, you guys know.
Let me read
Crack
Everyone here knows me. Everyone here knows me.
I don't know you.
Anyway.
What the fuck? I guess I'm.
Oh, cool.
All right.
All right, cool. That's good. What's your name?
That's Brandon. He's a cool dude. He does So you've been here. Tell him what you've been hearing about this awesome place. I'm glad that you finally joined us, even though it's after the show.
Right. So I've been a part of this server for actually over a year, I imagine now. Can someone check? I don't know. I've been here for ages. I just didn't realize anything even went on in this place, like at all. I know who you are, Brandon. I've known you from past fucking accounts. Even I've known you. So I know Kosho. I like Kosho a lot. I think he's a cool guy. In fact, actually, some of the flat earthers don't like Kosho. That's not me. I think he's cool. But yeah, I just got told that there was maybe a little bit of debate going on over here. So I thought, I'll come over. I'll join. I'll get.
Oh yeah, we get it in every night at 5 p.m. Eastern. 5 p.m. Eastern, Crack. Come fuck with us.
I can read.
That's my time. That's 1 in the morning, though. I think. I'm not sure. That's maybe
British
why I've not been here.
That's terrible timing for you.
I can read this definition in the physics definition of the word medium. And it says in physics, medium is defined as the substance that transfers the energy or light from one substance to another substance, or from one place to another, from one surface to another.
Okay.
And the medium acts as the carrier here, and the medium can transfer any form of energy, sound wave, light, and heat.
So light goes through a vacuum, therefore a vacuum is medium.
Yeah. Yeah, exactly. So do radio waves. So do radio waves. Good point, Brandon.
Yeah, that's radiation.
It is a medium.
Radiation.
It's a medium.
Radiation doesn't need a medium to travel through.
Yeah, but the light.
If you keep looking up definitions of medium,
he said light.
Well, you'll come to radio waves.
He had light in his definition. You said light.
So you're not agreeing with the. You're not agreeing with the medium. You're not agreeing with the definition you just said. Then is that what I'm hearing, Kosho?
No, I think that you guys invented that. I said that it light, but it doesn't transfer radiation. Like a medium is not going to transfer radiation. Radiates away from something. You don't need to radiate
again. Let him read it again.
But a vacuum, right? I just wanted to say that a vacuum isn't how. I mean, because the vacuum is conceptual, right? Unless you pull as much air as possible here on Earth outside of a chamber, and then you call that a vacuum. But the vacuum, as they theorize it to be, we don't know what would happen in that kind of situation because that's just a made-up scenario.
You know, because I had already addressed that. I said that we're talking about near vacuums. Even outer space is a near vacuum.
Wait,
because there's nowhere you can draw a perfect vacuum.
Read your definition again.
Right?
Yeah, read that shit again, bro. Post it in the chat or something.
Okay, hold on. At the very end, it says the medium can transfer any
substance
form.
that energy propagates.
At the very end, it says the medium can transfer any form of energy, sound wave, light, and heat. It does say that.
There we go.
Yeah, but that doesn't say at the beginning.
Took a lot to get it out of there, Kosho.
Yeah, but it's saying the medium can transfer that. But whenever you're describing the medium, you're talking about the energy.
Dude,
that's
stop
transferred.
pushing that goalpost so far, so fast.
It's not pushing,
What Kosho is saying, guys, let me just. I think what Kosho is saying is that just because a medium is denoted as something that can do said things, doesn't mean it's something that is a medium can always do all of said things. Is that correct, Kosho?
Kind of. It's saying that the medium can do that, but it's not saying that a medium is the only thing. Like, it doesn't say you need a medium to transfer light. It certainly doesn't say that. But it does say that the medium is described as the substance that allows that is making this transfer. So when you're transferring heat, for example, you can do it by radiation, which doesn't need a medium, but you can also do it by convection, which does need radiation.
With radiation, it's at the point of we have the same with, let's say, a fire, which someone told me this is completely fallacious. That you have a heat source, which is a fire, right? Okay, so this is thermal exchange and where thermal lands, as in, right, you have a fireplace. You cannot put your hand in the fireplace, it's too hot. The medium in between you and the fireplace and the ceiling above the fireplace, you can put your hand. But if the fire has been burning for so long, right, okay, the actual ceiling above will be so hot you cannot put your hand on it, right? Someone told me this is fallacious and it doesn't work this way. I know that's not fallacious. You remember, Elijah, when I got straw manned on that on 24/7. That I was saying that, something completely wrong apparently. But I think all of us here would admit that, you could easily put your hand above a fire, but maybe not so much that if there was a ceiling above said fire, you might not be able to put your hand on the fucking ceiling. Well, I think radiation works in a very similar way in which that, yes, it transfers through maybe a medium or non-medium.
Correct.
But the place where the radiation lands will become irradiated. As in, for instance, with a microwave, right? A microwave ends up with an ambient heat inside of the microwave due to the fact that all of the radiation of where it exits and then enters the thing that is being irradiated, that in and of itself, the energy transfer into the very object that's being warmed up in the microwave, that starts to then convect out heat, right, into the actual medium itself. But the actual radio wave itself might not be hot in between its exit point and its entry point into the thing that's being warmed up. So I would say it's similar to that, like where heat starts, where heat lands, and in between is two different things, right?
Well, you're talking about the transfer. Yeah, so that's two different ways to transfer heat. That's right. There's convection, in which it needs to physically come in contact with some other substance, or there's radiation, which doesn't have to physically come in contact. Like the microwaves can be transferring, and it's not going to be hot until it reaches something that it heats up.
Yeah, like that's why a microwave ends up with an ambient temperature. It's not because it's not because there's radiational waves going off in there. It's because those radiational waves hit something, it transfers its heat into it via it permeating through it, and then that thing then releases the heat therein which it gathered from the radiation itself into the whole of the actual microwave. That's why a microwave becomes warm inside. Am I correct?
Yeah,
you are correct.
That's right. Those are two forms of heat. Yeah.
Can you post that
Or energy.
definition?
So why is it that gravity is the only scientific discovery that is done within a vacuum? I mean, how many surgeons do you see? How many surgeons do you see doing surgery in a vacuum?
That question makes a lot of sense, and it's worth answering. But I'm not going to. I'm sorry.
So we agree now that vacuum is just a lazy word for
real
air
science
at a lower pressure,
real
right?
Well, vacuum is a lengthy word in order to say privation therein of what? Like a vacuum can be a privation of light as well as a privation of gas. Depending on
you ain't going to do any scientific
in terms of
experiment
vacuum
in a
chambers, it's just air
gravity,
at a lower pressure. It's not a privation of air, because then it's a privation of some air.
Some air.
Yeah, privation of some air.
You took the air out, but
you're not really using the word privation right? It's the point is it's just air at a lower pressure.
This is my point. This is my point. Is that this is where words matter, right? You know, Witsit would say privation. I would say, well, no, a shadow would be a privation of light. But then also we could say that the shadow itself is due to the fact that there was light. So is it a privation of light, or is it a actual thing that exists due to light, right? So like it's quite difficult when these terms, because they're quite choppy and changing in the sense that they're not exact.
No? Exactly, and privation itself isn't exact, because you could have a shadow that's not like completely dark, and then you could have shadow that's kind of like faded a bit, and to say one is a privation of some light and the other is privation of all light or most light, it just gets dicey. So it's easier to say a vacuum is just air at a lower pressure. Simple as that.
They don't redefine the word vacuum. They just call it a near vacuum. And there's terms for the different parts of a shadow, like the umbra and penumbra and stuff like that. So they classify these things.
The whole reason you guys are talking about this is because we was arguing whether or not it's a medium, and it is.
So Kosho, they say a near vacuum chamber?
Yeah, near vacuum, yeah. If somebody
vacuum chamber.
Yeah, and they say vacuum for short. Like if somebody wants to if somebody was arguing against them, they'll be like, no, it's not a vacuum, it's a near vacuum. And they tell you the exact pressure is in there. But if they're talking colloquially or to each other for time, they'll just say vacuum. But
exactly. So my point stands that vacuum is just a lazy way to say air at a lower pressure.
Yeah, and the shadow is just a lazy way of saying the penumbra, the shadow. But you don't want to say like the whole part of the word.
Not true.
The exact specifics. You just say like a very general term.
No, because you could have umbras of shadows as well.
See, you can get a perfect. You can get a perfect vacuum regardless what they tell you. You can get a perfect vacuum.
No, you can. Don't lie.
Let me explain how. The Mythbusters did it. Right?
Fuck the
Mythbusters.
Took a damn.
Well, hold on. They took a railroad car. I said this the other night. One of the ones that carry the oil, the big cylinder black ones, right? And they sucked all the air out of it. They turned it into a vacuum.
They didn't get a perfect vacuum.
Let me finish, and I'll tell you how you get it. Let me finish.
You're finished. They didn't get a perfect vacuum.
Yeah,
let me finish, and I'll tell you how they got it.
Go ahead, man.
Okay.
The only way you can get it, obviously, is for probably less than a split second, because once you achieve it, the container's crushed.
They didn't achieve a perfect vacuum. No. They can't.
You always have matter in there.
Perfect negative. Once you get that perfect negative pressure, like he's saying,
negative pressure.
The negative pressure is not a perfect vacuum.
I know people say that it don't exist.
The other way.
Well, hold on. You can make the train car explode, and you can make it implode. Those pressures are in opposite with each other.
It doesn't matter. Matter
still
exists, so it's not a perfect
there
vacuum.
is a negative, whether you like it or not.
Just because it's in equilibrium doesn't mean it's perfect vacuum. Perfect vacuum means no matter. There's still matter going its different ways.
Right before it crushes,
vacuum, the end.
Right before it crushes, or right as it crushes, that's the perfect. That's the
no, it's not, because there's still mass airflow rate in the opposite direction.
You can't work with it.
So there's still matter.
Less than 1 psi.
Guys. When I came in, I asked what the point was. I'm still trying to figure out.
That's fine. Well, just keep listening.
Once we agree on terms, what is the next step?
Like, just listen, and then you have to read a commentator. But fuck.
We're saying a vacuum's not a medium.
No, James. But
it requires a container.
James, the train.
So
car,
it is a medium.
James, the train car doesn't even need to be close to a vacuum to do that. It just needs to be less pressure than the air. So much so that the inward pressure from the atmosphere is able to crush it. So it's
more than that's correct.
Before you get to that, you got a perfect vacuum.
Let me just try and clarify. So to say something's a perfect vacuum because something implodes, right, is not directly accurate, because something can implode based on its tensile strength. So I've used vacuums with bell jars, for instance, and they haven't imploded at the same pressure rating as when I've used something that's of a lesser tensile strength, i.e. an aluminium can, right? So the aluminium can could withstand less pressure pushing into it, trying to get into the negative zone, as opposed to the bell jar that would never implode at the same negative pressure, right? This is now.
Could you ever create a vacuum by blowing air out of it? No, you got to suck. You got to suck the air out of it. You can't blow air out of it. You're just blowing air into it.
Regardless, depends actually.
The only way to get a vacuum is by sucking the air
out of it. You're going to be blowing into it.
Not true.
And a container.
Wait there. There's actually something called Dragon's Breath, which is something they use against road mines and IEDs. That actually you can create vacuums using these things. So what you have is you basically would have a let's say you have a chamber, right? That's not evacuated of gas, and what it does is it actually uses a high heat, either magnesium, whatever it is, or a form of basically very, very, very high heat, powdered slow burn, but very high heat. So you would melt through one side of a piece of glass, like a glass capsule, right? And it melts through the top, and as it does so, it has enough force in order to burn all the gases out and then melt a hole in the other side. And then at the end, if you keep burning, eventually it will self-seal on one side, and then eventually the other side seals again. And this is all a forward blowing mechanism, but at the end it's got a low enough pressure in the side that eventually it just self-seals on one side, self-seals on the other side, then it implodes. So that's blowing.
Well, you're still making my case for me, but even saying that, all you're really saying is you can't make a perfect anything.
You can make a perfect vacuum, though.
You can't make a perfect anything.
How do you make a perfect vacuum?
You only emphasize vacuum.
You don't care to find out, it's fine. But you can make a perfect vacuum simply by making a barometer. If you use distilled water, for example, and you were in a cold room with little light,
well, this is irrelevant.
You could make a perfect vacuum by making a barometer, which works by making it. Which works by pushing the water.
This is why I tried to say about the semantics of what we're trying to talk about, because I want to get to the crux of actually what we were originally talking about, because I wasn't here for that. Eli's brought me in. I've not got much time. I would like to know what the actual argument is, so that we can try and get to the actual argument, so that we can try and move forward, right?
Well, what I was saying is separate from this. This is a conversation about
nothingness.
Okay, you talking
Elijah.
about
Here's the relevance. Here's the root. They're basically trying to say that things fall at the same rate in a vacuum, but the other hand, they're trying to deny that. Like, they're trying to move away from the fact that there are no perfect vacuums.
No, this is from Brendan. Brendan asked Left Lane something that he brought up in the show. He was just asking why he said something he said in the show, and what he said was that vacuums aren't mediums. That's all he said, and that's all this.
Right.
from that question.
I got a little overly pissed off about that during the show. I do apologize for that, Howard.
Right, so a perfect vacuum a medium? Yes or no?
Perfect vacuum wouldn't be, but it's.
Wait. Would light be able to propagate through a perfect vacuum?
Yeah, it would.
So is it a medium? Yes or no?
No, it's not. The medium describes the substance, and the vacuum is the lack of substance.
I get that. I'm asking you whether or not. Right. So from your description of earlier, it seemed to make it sound as if if something is able to propagate through said thing, that would be what would make it a medium. So that's
energy propagating through. Light is energy, so even if it had no matter, if light isn't of matter and it's propagating through it, then it's still not a perfect vacuum.
No, what it says is the medium is defined as the substance that transfers the light or energy from one substance to another. So the substance that's transferring it is the medium. If there's no medium at all, like I said, the analogy would be like a vacuum is to, a medium is to a vacuum as a quantity is to zero. Because even though zero, we now consider it a number, they didn't consider a zero number for the longest time, and it really is the lack of numbers.
So how would you have light propagate through nothing then, if it needs a medium to transfer?
Light doesn't transfer substance to substance.
Well, how would it propagate?
I'm saying it's not needed. Like you can.
That's powerful.
This is all just speculative bullshit because we don't have light.
You
that's
can
not
make
in
light
medium.
travel substance to substance. Like if it's in a medium, it can travel substance to substance, but it doesn't need to.
You can't even. You're just making an argument from ignorance because you have no perfect medium to actually. No, you can't say it's the truth because you can't prove it. So it's
I can tell you this is the truth because you can make a vacuum chamber which is only a near vacuum and the pressures are decreasing.
It's a theoretical hypothesis.
Elijah, I'm finished. The gases are leaving.
So a medium defined
being able to
transfer.
Hold up. You can't get a perfect vacuum, so it's a hypothesis.
He said to let him finish, and I
quick
don't want to argue about that.
Yeah, the light. A vacuum chamber, you can decrease the pressure to almost a vacuum, and you can take out the molecules in the substance till it's almost empty, and the light that's inside of the vacuum chamber is never going to get less bright. It's not going to dim because there's less particles in there.
Right.
Okay, I really don't care because we're talking about things falling at the same rate, and I really don't. Like,
That's it.
I'm trying to. I brought someone here because I want to get back to how gravity isn't the justification for the Earth being a first law of thermodynamics violation.
Right.
If we're to beg the question of the creation story, I want Kocho to repeat what he said earlier about electromagnetism and all this.
What? Oh, what you said about how it's a violation, but right. So those forces aren't a violation of the first law of thermodynamics, because these four forces that we have, like electromagnetism, for example, it's described. So the energy is not being created out of nowhere. In order to have two electrons oppose each other, or two negative things oppose each other, they're actually transferring photons from each other, which is a transfer of energy. So the energy is always there and always exists. It's not being created because the force is being is because there's a force happening. Those four forces aren't a violation of the first law.
So I might be in complete ignorance here. If I am, then help me out.
God damn.
But if you bury a light bulb 20 feet in the dirt,
oh God,
20 feet above the dirt,
can you see the
light? Can you see the light?
No, you can't. But I think Elijah was.
So is the dirt?
I think Elijah was making a point.
Oh, hold on. My question is the dirt not a medium? Because you can't see the light.
James, I don't give a shit about that conversation. It's boring as fuck. I asked if everyone was okay with moving on because I brought someone in to have this conversation, and then I laid out what I laid out, and Kocho was repeating what he repeated earlier, and now you're going back to the other conversation.
I stepped away to go use the restroom, so I came back. It was this. I stepped away when you said that, but I came back and it was the same conversation. I apologize.
No worries,
Fair
dude.
enough.
Don't worry.
Fair enough.
Oh, I cut out anyway, so I didn't hear a word of what Kosher said. I completely cut out for some weird
Oh
reason.
my god.
I don't know, dude. It's fucking so
What
annoying.
Not
is
your
up?
night alive.
So can you say
I
can
feel
you say
free,
the thing
like
about the
in one sentence.
because
Yeah.
it's yeah.
One sentence, Elijah had said something about the first law of thermodynamics. Matter and energy are never created or destroyed. He said that it's violated by gravity because it's this thing that's giving things energy and causing them to move together. And I'm describing that energy and forces are not the same thing. And another example of a force, like electromagnetism, can cause things to repel each other or attract each other. And the way they do this is by exchanging virtual photons, which is energy. It's an energy transfer. And the energy is not being created or destroyed. It's just being transferred.
yeah, yeah, but the point is with that, right? Cool. So you're saying that sounds different to what I heard you may have said, but in essence,
Right.
right?
He didn't add all of that because I would have responded, okay,
Yeah.
how are these things interacting then?
Yeah, because that's the whole reason
again,
I was brought over, right?
I told you, they have opposite charges or they have the same charges, and those charges transfer those virtual photons, and that's how the
but
relationship.
that's after the assumption of an interaction, right? Because everything is expanding away from each other. So when does this occur to then see a reaction or an interaction?
Well, yeah. If you actually check out the contents of the Big Bang, all the forces.
Wait, can we just have this then? Wait, are you admitting then that in, let's say, the Cavendish non-experiment, that then you cannot negate for electrostatics? Because if that's the case, if there's only transfer, right? So let's say via using water, right, for instance. Well, where does if it can't be destroyed and it can't be negated for, right? Because where does it transfer to? Have you got the object or they're in the medium in which the electrostatic nature that is within that you would use, let's say, water in order to get rid of it? Where is it that it's going to so that it cannot be a part of said experiment?
Right, so the electromagnetism and the transfer of photons is not happening
Electrostatics
with gravity. So that's just electromagnetism. With gravity, the cause is said to be the mass distorts space-time, which makes the objects appear to be moving towards each other, and which actually in our frame, which is the frame on it, it actually does move towards each other. So it's actually the frame, it's actually the construct that is space-time distorting that makes the objects move towards each other. So it's not a violation. It's a funky phenomena, just like electromagnetism is a funky phenomena. We understand how it's doing it, but nobody understands who made the rules and why it's doing it. It still is not a violation. There's not energy being created because of this.
Well, I'm not saying energy is being created. I'm saying how would you exclude for electrostatics in, let's say, the Cavendish non-experiment, when you're admitting yourself that energy cannot be destroyed. So, i.e., if you try to negate for the electrostatic nature inherent inside of the objects that are apparently coalescing toward one another to show mass attracting mass, in the thing that was apparently even meant not to show that, but obviously meant to show the volume of the Earth, or the mass of the Earth. I'm saying, how do you exclude for electrostatics when we do not have a clear paper that shows where the electrostatic nature of these masses is when excluded for, where that is being transferred to in order for us to control said variable? Because right.
There's two ways that you can not worry about that. One is, well, it's three ways really. You can eliminate the electrostatics from the Cavendish, but from all
you can't
those
eliminate. Wait there. You can't eliminate. Energy can only be transferred, not destroyed. You can't eliminate.
Yeah, well, you can eliminate it by taking it from the object. When you rub something against something and you make it more electrostatic or less electrostatic, you can transfer the energy. Yeah.
Yeah. Where is it going?
You transfer it to another object and take it from the system completely.
Right. So show me the paper that says or shows where it's being transferred to.
Well, that's one way you can do it, and in all the Cavendishes, I mean, they'll probably describe that in the paper.
They wouldn't.
Well, in this, regardless though, the reason why you wouldn't have to worry about it is because what
No, I'm worried. Listen, wait there. I am worried.
I'm almost finished with the explanation, but yeah. So that's one way you can eliminate, or you can eliminate if you were worried about it. But the reason why you don't have to worry about it is because the quantities and values you get as the conclusions to any Cavendish test, or Cavendish test, is the values. The force changes by the amount of mass you're using, and not by the different objects that will have different electrostatic potentials. Which you would think, if that was the cause, that would change the values that you get at the end, but they don't. And the other thing I said when Paige had brought up what you just brought up is dropping objects in a vacuum. When you drop objects in a vacuum, to calculate the force that you're going to get from the falling object is going to be the acceleration, which is usually the same on Earth, multiplied by the mass. So the force is going to be directly related to the mass, not to the electrostatic potential.
Here's where I interrupt again. So you agree when you drop things in a vacuum, there's nothing to, there's no friction, right? So it's going to move unimpeded, right? So when I ask you about the vector opposite of the initial point, it's moving in that direction unimpeded, and you're telling me that there are forces acting upon particles because of an interaction. But how is anything interacting with all matter when all matter is moving in the opposite direction of its origin?
Well, also, just to say this also, when they're talking about dark energy is technically spreading the space out. It's not really by extension, the objects will spread out. But because these forces are stronger at a smaller scale, they stay close together. And so it's not that they're violating, one's violating the other. They're two different forces opposing each other. The same thing as something falling. When something's falling, there's a force making it act downwards, and there's also a force acting in the other direction, the drag. But they're not what's the word? They're not violating the other one. They're just counteracting each other.
So you're saying that the Cavendish experiment overrides Earth's gravity and does it laterally or horizontally?
You're right about the last part of what you said. That it does, but you're wrong. The override, I wouldn't use it. It works horizontally because gravity is working vertically, and you can disregard downward force because it's already accounted for. It's not going to be. You're not going to take away from it by creating a force in the lateral direction.
I'm just wondering how these two variables being measured on an extreme sensitive tool, right? He even admitted that it had to be so sensitive, paraphrasing, that a cockroach could fart, change the result.
Did somebody actually say that? The cockroach?
I'm just paraphrasing, man. So he had to, it's very sensitive mechanism. Like if you let a tiny bit of air in the room, it changes the result. It could have been anything, right? And he didn't have hold on. He didn't have a video camera, right? He just went away and came back. He didn't observe what took place when he went away. You call that science?
He's not the last person to do it. And the thing is, when people do it
science
today,
would observe the whole experiment,
the same value
in its entirety.
You're assuming he wasn't there the whole time for whatever reason. But regardless of that fact,
well, you couldn't have been there the whole time.
We see people do it today, and
look how long it took.
They are observing it the whole time.
Oh, okay, all right. So you never looked up the Cavendish, and yet you're using it?
What are you talking about?
The Cavendish experiment. Do you know how long it took?
Why are you saying I never looked it up?
How long did it take for these to variables to attract to one another.
It took them a whole summer to get the
Right,
experiment done.
they was there the whole time watching it.
Not because the test took that long. It's because he was trying to be careful, and there was variables that got in the way. He keeps starting over.
Well, you realize that according to your story, we've landed on the moon since then, and there ought to be 50,000 other experiments that abolishes his, because how old it is, and fine tunes it like a guitar.
There absolutely is, yeah.
Or a piano.
I've posted one.
But there's not. Obviously, there's not, because you're still using Cavendish.
No, you brought it up.
No, flat earthers, they don't bring it up. Globers bring it up.
Sure, Cavendish is a great test.
They don't bring Cavendish. It's not an experiment.
Attracting mass.
There's no naturally observed phenomenon. There is no experiment scientifically in the Cavendish because there's no naturally observed phenomenon.
Yeah, there is naturally
There's
observed
none.
phenomenon. Of course there is.
Oh, okay.
Things
Okay.
falling. Yeah.
Well,
Objects
things
orbiting.
falling is not natural, right?
Yeah,
I mean, you could really.
Yes, things naturally fall all the time.
So you witness like a rock on a hill, and it slowly, the earth under it slowly deteriorates because of the wind and rain, right? And then you see the rock fall. Then you see the rock fall, and you're like, wow, I wonder what made that fall. Well, there's no longer nothing underneath it.
Water falls
Problem
and
solved.
rain all the time. Things fall naturally all the time.
Yeah. No, they only fall naturally because of earthquake, weather deterioration. Sorry, I'm having problems with that word.
And if you were a fish,
they only fall when there's nothing underneath them that's more dense than them. And if they're less dense, they'll rise.
James, you're right.
Problem solved. That's why things fall.
Yeah,
There's nothing underneath it.
You said things did fall naturally. I'm not going to argue with this anymore.
Yeah, within the medium of air, we live in the medium of air. Therefore, air is natural to us, to you and I. To have this conversation, we need air. So that's reality. Now, when there's nothing underneath the variable, a rock falls, right? It's because it's falling through the medium of air until it hits something more dense than itself. And if it's less dense, it rises. Like, how hard is that? That explains it all. How hard is that? All of it's measurable. You can vary, manipulate, control, isolate, all of that.
All right, hey James,
that only works if the earth. That only works if the earth is flat. If it's a sphere, they need a force pulling things to the center.
Right. I got a question for both of you guys.
Yeah, you gotta have a force.
You guys can work together to try to answer this, or
that's
you can.
The point.
That's why they cannot get rid of.
I got you, man. I got you.
That's why
we need it to be flat. Otherwise, it's okay. So I got a question for both of you guys.
But you can't isolate, vary, manipulate, or control gravity. Yet you call it science.
The only reason I let you run on so long is because I was just about to disengage.
Everyone had a turn to talk. It's Kosho's turn.
Yeah,
please.
Just a quick question. You just said the upward, it's relative density, whatever. The question is, if I were dropping an object into, so I'm doing an experiment where I'm dropping an object into a vacuum chamber, and I also put a balloon at the bottom of ping pong ball at the bottom of a pool of water outside the vacuum chamber, and all I want to do is I want to predict what force it's gonna what force is gonna be at the bottom when I drop the object, and what force is gonna be acting upwards whenever I measure the upward force of the ping pong ball. So how would I come up with both those values?
Involved, buddy. There's no force involved.
I just want to remind you that a force can be measured by a scale. Yeah, so you can there will certainly be forces involved in both these things. Their mass is accelerating, so there will be forces involved. And my question is, what force, or not what force, but what would you use to calculate those forces or to predict those forces?
A scale doesn't read a force, Kosho. It reads the pressure that you apply onto that.
Okay, I'll help you out, Matrix. Pressure is a force at a specific area, so it is reading a force. Yeah.
Are we still begging the question of gravity?
Say again?
Are we still begging the question of gravity?
No, I'm begging the question of how would you calculate those the force involved? And since you guys don't want to answer, I can give you the simple answer. You can use the acceleration of the object is falling, multiplied by its mass, and then the amount of time that was falling, and that will give you the force that the force that it's built up in.
Yeah, but then we would be lying, Kosho, because we don't know the volumeric mass of the Earth itself. In order to be able to denote exactly what that would be, we can't lie about the volumeric mass.
Why would that? I said you're dropping an object in a vacuum. Drop an object in a vacuum, and you would determine.
I know.
Yeah, but
I
what is
know
that?
What you said.
Why would I need the volume of the air?
All right, I thought you were talking. Listen. I thought you were talking about in relation to the Earth itself for a moment, for some reason.
I'll ask again, but just very quickly and simply.
I disconnected and come back. I'm sorry.
That's fine. It's fine. I was asking those two, but anybody can answer, I guess. What calculation would I need to predict the force that an object that I'm dropping in a vacuum chamber, a ball in a vacuum chamber, what would I need? And then also a ping pong ball at the bottom of a pool, what would I need to determine the force of that it will have at some force reader at the top of the pool when the ball comes to the top?
So we need to know the drag. Oh, my bad. Go ahead.
Yeah. You would need to know the resistance, right? Well, this is why I would say that you cannot ascribe gravity in and of itself to be a force, because things would fall at a uniform rate regardless of the resistance. If I have a resistance, right? If I have a force, right, that is able to push a ton piece of weight through water, right, and it's an actuator arm that's hydraulic, right? It will push as long as the resistance isn't greater than the tolerance that the thing I have of its force, of what its tolerance is, of what it's able to take. That arm, the actuator arm that's hydraulic, will push anything through a medium with a resistance that it is capable of pushing past, i.e. its force value, right? So this is why gravity isn't able to be ascribed as a force, because gravity apparently is attaching itself to objects that fall, but they differ in their fall rate based on the resistance of the medium. Well, a force is exactly the opposite of that. A force would be something that gives no fucking shits therein of the resistance. It's a force. Once it has hold of something, it will force its way to pull said thing at the uniform rate in which the force is capable of achieving, because it's a force. Gravity does the opposite of this. Gravity is actually, i.e., not able to pull things based on the differentiation of its surface to area ratio, sizes, and all this shit against said resistance of the medium that it's in. Wind resistance, air resistance, whatever you want to call it. Why it can't be a force.
Okay. Well, what I was asking was about the how you would predict it. So that's true. That's why I said you would drop it in a vacuum, so you wouldn't have to worry about the drag of the ball. But very simply, you would need to know the mass of the ball.
That vacuum, as we've admitted, cannot be perfect, right?
Yeah, but no matter what vacuum chamber you use, it's not going to change the speed of a ball if you're using the precision of decimal places of a second. I mean, of a force.
But then the thing itself is more dense than the medium it's in, even if the medium
again, it's not what I'm asking. I'm not asking why. I'm saying what would you need and how would you calculate it? And the answer is the answer for the downward one is you would need to know the mass and the acceleration rate that is falling, and then the height of it to know what that distance is going to be when it finally gets there. That's what you would need to know to determine that, because the force at the end of it is going to be related to those values, and the ping pong ball acting upwards is going to be dependent on the force acting upward, which is going to be based on the weight of the medium that is displacing, of the volume that's displacing, that's acting downward. So when you say relative density, equilibrium, all sort of type of stuff, in both cases they're due to the mass of the object and the force that is pulling that mass down. And that was the whole point of
If it was a perfect vacuum, which doesn't exist.
No, not if it was a perfect vacuum. The precision that you would need for a vacuum chamber to give any kind of measurement drag or something like that in a vacuum chamber, you're gonna need like, I don't know, 50 decimal places or something like that. Like it's
but the longer.
Listen, what you said only applies to a perfect vacuum, because then you don't have to worry about the space that it takes. You don't have to worry about volume. You don't have to worry about air resistance and all of that stuff. But if you are actually talking about real life, we don't have perfect vacuums, so you have to incorporate the volume, which means it's all about the density of the object. And yeah, sure, if you have two different objects that are the same size and same volume taken up, then you could discount the volume and all that stuff, and it would only be to matter or to mass or whatever you want.
Let's say that we only
in the end, it's always about density.
Let's say we only need the precision of 8 decimal places. Okay, 8 decimal places, which is much more than you would ever need for anything ever. You're never gonna.
Come on, Coach, dude.
Yeah, if you have precision, if it's not that precise, but listen to what he's saying. He's saying that because it's not a perfect vacuum, there's going to be some amount of drag in there. There's going to be
even like a really negligible amount. Listen,
it's never going to affect any test you ever do.
Okay, Kosher, but it's still density, and then you're just making the volume equal or negligible. The differences in volume negligible, but it's still density.
Well, it's the fact is that still drag is going to have to be added into the equation for you to get a perfect prediction.
No, forget about that.
You don't need to make a perfect prediction. You don't need to make a perfect prediction. You just need to be accurate. Only 8 decimal places.
No. Don't worry about that. Don't worry about air resistance. Don't worry about that. Let's say we made volume completely the same between two objects or what have you, right? All that will matter then is the mass. That's only because you're making volume completely the same. So in reality, what's density? Density is mass over volume. So if we're making volume canceling it out between the two objects, then yeah, the mass will matter. But all you're doing is taking density and boiling it down further because you're limiting one of the variables.
You can make a perfect vacuum chamber, and in making a perfect vacuum chamber, if anybody wanted to do this to see if there was any answer that wasn't more than some fucking very small decimal place.
So you're lying. You can't make a perfect vacuum. Thank you.
You can.
I don't know why you just keep on trying to detract away from density.
Kosho, you can't make a perfect
well, let's
vacuum.
not say he's lying. Wait there, guys. Dad, let's not say he's lying. Let's just say that he is mistaken.
Let's find out. If you have a flask or a beaker or whatever, that has a tiny neck and it's like a 2-foot long neck and a very, very large base that's round, and you pour the whole thing with mercury. You pour mercury in this whole fucking thing, and then you put a plate that you're going to put this in, and you flip the whole thing upside down so that almost all the mercury falls out, but some stays in. What's left in that cavity is a perfect vacuum. There's no air in there. There's no anything. It's a perfect vacuum. All the mercury is below.
That's actually not. No, that's not a perfect vacuum.
What's in there?
What's in there? You're saying that you filled it with mercury, you turn it upside down, mercury starts to pour out, right?
That's right.
Right. Does all the mercury leave?
No. So the part above the mercury, the part in that cavity there, and that cavity is
that.
Yeah.
So you can't operate in that field, though, right? You can't do anything to that.
You can't
particular area.
Right?
You could if you actually wanted to. Yeah.
Like what? Give me an example.
Let's say you wanted to measure things falling in that cavity.
How would you put anything in there to fall?
You would put them at the bottom of the flask. You put them at the bottom of a flask and have some kind of electrically controlled contraption that you can control from the outside that you could press.
The actuator arms wouldn't work, would they? Because there's no medium in which for energy to be transferred into it. Then that would mean it wouldn't be a perfect vacuum again.
No, you would just use an electrical component. What were you talking about? You just need an electrical component with a motor on it or something.
Which would then disprove your whole idea that it was a perfect vacuum in the first place, correct?
No.
It worked.
Why? What would be?
There's nothing on Earth that is capable of any of these thinkings without man's concepts behind it to validate a supposition. Point is, an object would change. The object would change its in a real world. An object would change its velocity based on the medium around it. Dropping things into heavier mediums would slow it down, right?
Yeah, and if you have no medium at all,
changes,
you have no medium at all.
Changes, right?
If you have no medium at all, you can see
but
how
that's
fast
not
we fall without a
reality,
medium.
Kosho.
Yeah,
That's
you
not
could do this in reality.
It's not
They make
reality,
barometers
though.
almost every day.
We don't live in a world that has no vacuum. We live in a world that's got a medium
In a
around
world
us.
where vacuum is keeping a man down. Well, Kosha, this is my whole point and why I keep saying that gravity cannot be ascribed as a force because of this reason. It wouldn't matter about the volumeric size or the mass or any of that shit because gravity apparently once attaches in itself and once something is affected by gravity itself, once it holds on to an object, it being a force would mean that 9.8 meters per second or 9.8 meters per second squared, that would mean that the object would be able to fall at that uniform rate regardless of said resistance around it because the force would force it pass through any resistance regardless, right? And that's my whole well, a force, yeah, that's true.
An airplane, for instance, has 4 forces acting on it at any given time.
Oh my god!
And so think about the drag of an airplane and the thrust of an airplane. The thrust of an airplane doesn't.
Not in a vacuum, Kosho.
The thrust of an airplane doesn't outdo.
Not in a vacuum,
the drag.
Kosho. Why are you using?
You have to
it as an
add them
example?
together.
You're not. It's not in a
I'm
vacuum.
not saying that, Kosho.
Yeah, you're saying that a force would push past the medium, regardless.
I'm saying that a force, as described, is something that is able to
pass through a medium that is less force.
Yeah, it does. Things fall in water and things fall in vacuum. I mean, in air.
That's right. We don't have vacuums,
so it's a
buddy.
force.
Kosho said
the
earlier.
kinetic pressure that was provided to the object, right? You have to keep in mind what is the fundamental kinetic energy provided to the object.
I'm still wanting to get to what I wanted to get to earlier, which was that with the Cavendish so-called experiment, right, where you say that energy can only be transferred, not destroyed, right? And you say then, oh, wait there, we can negate for, or what was it that you actually said? We can exclude electrostatics, right? Between the masses in order that we don't have that as the cause of the effect of what we're seeing, right? Well, I would love to actually be able to be shown how you negate or exclude for electrostatics when you cannot show me the apparatus in which you transfer the energy of the electrostatic charge therein to the other thing in order that we can actually see, because you can't just say, oh, we negate for it, we add water and that would get rid of electrostatic charge, right? We can't say that. We can't just say get rid of, because we can't destroy energy because of the first law of thermodynamics, right? We can only transfer it, it cannot be destroyed. So with Cavendish, I would love to see where someone did the Cavendish experiment and then they showed me where they transferred the electrostatic energy into something else as to show that the balls coalescing, or should I say attracting toward one another. I would love to see where those masses attracting toward one another with the exclusion of electrostatics, how they excluded therein for it, and show me the very apparatus in which they used in order for it to be transferred to, so that we could then remove it as a possibility of a cause of the effect, so it's not a reification.
Okay, what I told you before was that you can.
Yeah, I wasn't happy with it.
I know you can take them from a system by removing them as best you can.
I want to be shown
I know. Cavendish did this as well. But you can do that to remove as much as you could. You can remove as much as you could. Hold on, man. Hold on. It's not a complete answer, man. It's not a complete answer.
Coach. Let's let Kosha finish.
Yeah. So you can remove as much as you possibly can. That's one way to alleviate the issue that you think might be arising. But one way that you can certainly eliminate that idea that it would have anything to do with that is by the fact that the amount of mass that you use is put into the equation to determine the force that's acting on it. And it's always, you get the same values when you do it because you're getting, the force is being done, I mean, the equations are being done correctly. They don't include electrostatic potential. They include the masses that are being involved. And yeah, those are in the equation.
That was my whole point. So they're included in, but you can't show me any of this. Is what I'm trying to say. I'm yet to read a single synopsis or even there in a actual full report on a experiment, the so-called Cavendish experiment, that shows the exclusion of electrostatics or any of these calculations. I've not seen this yet. This sounds great conceptually as you speak about it, Kosho, but like I'm not seeing it anywhere. No one's showing me this shit. Never have been shown it yet. What? It gets asserted.
Well, that's what I'm saying though. When you look at the equation, the force equal to the big G over of the m and the m over the distance between them squared. When all they're putting is they're putting the masses in there each time. So you're not at all including the electrostatic potential, which is going to be different for different objects regardless of the mass.
Then you could say that electrostatics hadn't been negated ever in any of these things, because this is just all conceptual, sort of abstract. This is conceptual and abstract because, like you said, like no one has shown me a paper yet where it shows that they are removing this as a potential for the cause of the effect.
I'll post the paper again. In this paper, they describe the entire process to what they did.
Can you DM that to me? Is there any way you can DM that to me?
Sure.
Thank you very much.
But yeah, but the equations, like if you have two different size masses, two different distances apart, and you measure the Cavendish experiment, you get the same value for the big G. So you get the same value for big G. If you put in the electrostatic potential and you don't include the mass, you're not going to get any value that correlates with any
Kosho, do you know that Coulomb did the Cavendish observation 10 years prior to Cavendish doing his? Did you know that?
Coulomb's law is similar, and
it's the exact same structure, the formulation as gravity. Okay. How close?
Not the exact same structure. It's
the same formula. It's the same formula, bro. It's the same formulation.
It's got a different.
The same
constant.
formulation.
No,
dude.
it's not. It's the same formula, dude. Like it's the same. Trust me.
So you know, Cavendish is not. This is not Cavendish's invention, right? Coulomb beat him to it 10 years prior. You understand that, right?
Right. His law has a different constant. You're not going to get the. You're not going to get the.
The only difference is he's got repulsion and attraction.
You
only have attraction in your calculation. But here's the thing: how close is Coulomb's calculation to Newton's? How close is it?
Very, 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 very.
How close is it you talking about the value?
The result. How close is it?
What do you mean?
You know, 6 to 10.
How close is the result?
What is it? 6 to the 10th, 42. What? 6 to the 10th power 42, whatever. How close is it to that?
Yeah, and Coulomb's law is a 10 to the 9th. It's 8.98 10 to the 9th, which is a very large number. The gravitational constant is an extremely small number.
Okay, so
no, that's a differentiation between. Yeah, it looks like a large number, but it's not a large number.
No, it's not.
It's not a large number when
he said results. Let him continue.
I'll write them out. Yeah, the result of the Cavendish experiment was the big G constant, okay, which is a very small number. I'll write it out. Hold on.
Yeah, but Coulomb's
very small.
They don't like Coulomb's. They don't like Coulomb's.
Not at all.
It shows basically the exact same thing.
Exactly.
Except that it says repulsion, right, as well as attraction. So what it shows, in fact, actually, is you can get the exact same thing.
Exactly.
That you apparently have from gravity, except
exactly
electromagnetism.
And 10 years beforehand. That's right.
Oh, I know that. Yeah, of course, bro. Like, we are on the same level of understanding. That's why it's good to talk to people like Kosho. This is why I want, Kosho. We're looking. Me and Batman are looking at trying to get you unbanned over it 24/7 because we need you there. We don't want people. Some people might not like talking to you just because they can't refute what you've got to say, but I don't care about that anymore. Sorry, I don't care. I want to be speaking.
No big deal.
I want to speak people talking to you.
All right. This is a bit. I appreciate that, but give me 1 second. I'm just gonna write this. I'm writing this out right now.
But yeah,
it'd be much quicker to just type it in.
Flat out data. If you have Coulomb's thing that you can send me, because my area got flooded, my whole PC got blown up. I've lost everything, dude. I mean, fucking everything.
You got flooded out? Where the hell were you living?
I'm not gonna dox myself too much, but I'll send you some stuff in DMs, and I'll show you what it looked like where I lived. I got flooded severely, bro.
All right,
my whole area.
All right, so I'm writing this out now.
It's not going to stop. The flooding will continue and get worse.
Well, I can protect myself from it for the future, but I couldn't then. repulsion.
Are you ready for? So here's the conclusion to both the results. This is big G. That's the gravitational constant, and that's Coulomb's constant. The K. Okay, these numbers are no way near each other whatsoever. They're not nearly close in any kind of capacity. One's extremely small, and one is very large. They're not in any way close to being the same value.
God.
Again, you're forgetting the main principle of repulsion and attraction, and the observation was done 10 years prior. So in other words, they were doing this before the whole density of Earth concept. So they were proving that electromagnetism causes the attraction and repulsion to objects is the point. It's not gravity.
No, he wasn't. He wasn't proving anything. He was measuring the force of the attraction.
Yeah, and that's what we get, dude. We get an attraction and a repulsion force based on electromagnetism. Cavendish doesn't do that. He doesn't add that in.
He's trying to establish a cause and effect relationship.
Where you're saying that the numbers are completely different or whatever, right? So in relation to what? In relation to the sizes of the masses and in relation to the cause of said attraction, right, and repulsion. So we have to extrapolate the data therein of both things in order for us to actually create to actually be able to create a chart so that we can actually get to the exact same tolerances that one is saying the cause of this is gravity, which he never even said so. But other people have ascribed it as gravity because it was trying to find the mass of the Earth. But anyway, it doesn't matter because we can extrapolate it down to where, right, this attraction and this attraction as opposed to gravity, right? When we have the same starting points for the same, so the starting axioms therein of like mass, the masses, the size of the masses, how fast the masses are attracted towards one another, and the cause being either gravity or attraction or repulsion, so should I say the opposite of repulsion. We then have to work out what the number would be, not just based on what the number you're looking at right now, but look at the number of what it would be with all of the actual values being set the exact same. Right.
Okay, so
here's this is from Crossroads Academy. The gravity force has the same formula as Coulomb's law for the forces between electric charges. I.e., it is an inverse square law force that depends upon the product of two interacting sources. This led Einstein to use electromagnetic force as the first attempt to electromagnetic force and gravity is the first attempt to demonstrate unification of fundamental forces. So Cavendish doesn't apply this electromagnetic force into his equations. Coulomb's law has a constant K, which is the Newton's gravitational constant.
Right. So again,
Coulomb's is actually more correct because he accounts for electromagnetic forces, plus he uses the constant. No, I'm not denying there's not a constant there. When you drop things, there's a constant rate of fall. Nobody's ever going to deny that. What's causing that is what we're debating here, not the phenomenon of things falling. So when you look at Coulomb's law,
I'm waiting to respond to him. I can't respond to the 5 points you're trying to make right now, man. Okay, just very simply, these two forces may look the same in structure. They both have a constant. They both have the distance between them, the inverse square law in between them. That's not that strange. The constances are both very different, which I just showed you. The other thing I want to show you is that the things that they're multiplying together at the top are also very different. One is the masses of the objects, and the other is the charge of the objects.
The K in the constant. Listen, the K in the constant is the number that equals 9 by the 10 power of 10 newtons in meters, right? 9 times to the 9 times 10 to the power of 9 newton in meters. The K, this is the K constant that's used in Coulomb's law. Okay, so he takes the 9 by 10 to the power of 9 and applies it to the inverse square calculation with the Q1, the Q2 over the R2. Okay, to get your attraction or repulsion equation, which you call a force.
What are the Q's in that equation?
The Q is the quantity charge, and they're both quantity charges, so they're the same.
They're two very different things for masses.
So listen. You have mass 1 and mass 2 in the equation of gravity, right?
Okay, so what happens if you have two objects that are both large and they have a magnetic? They're magnets. They're large magnets, Are they going to have a different
It's not
value
equated
than
for in
two large
gravity's
objects of
formula.
the same size that are
It's
not
not
magnets?
equated for. It's not equated for in the gravity formula, buddy.
Yeah, it is. It's equated for in the Coulomb's law. It's being talked
That's what
about
I'm saying. Coulomb's is more accurate.
It's Coulomb's law is talking about something completely different.
No, it's not, dude. It's the
Yes,
same
it is.
formulation.
It's multiplying two charges by a different number to get
Which
some
is
force.
reality.
Multiplying the masses by a different
reality. We don't have a
force.
we don't have a mysterious force. There's electromagnetic forces. That's the difference. Your gravity
What makes
is
one
invoking a
mysterious and
magical
the other
force.
not?
Your gravity is in. I can do the same thing with Coulomb's law you can with gravity, except for mine is counting for actual natural forces around, not a mysterious force.
Yeah, and if you were doing that, you would get a different value for a different force altogether. You're getting
for different charges, sure, but the charge
exactly.
the charge is still relative to the mass.
Yeah, but that's what I'm saying, Kosho. So if wait there, just to clear this up. So Kosho, if we can match the exact result of what gravity apparently is doing in the Cavendish experiment by us, let's say, manipulating and changing the amount of charge in the masses so that we get the same attraction rate, then what would you say?
I'd say you have something there. The problem is you can't do that. The problem is this is not the problem. Hold on. The problem is you can't do that. Because when you have two objects and you're setting them up as in the same way you do the Cavendish experiment, you would measure the charges to get the Coulomb's law, and you would multiply it by this very large number, and you would divide it by the distance between them. And what you're going to get is a totally different. You're going to get a totally different value than what you get.
The K constant in the Coulomb's equation is the same as Newton's. Do you understand?
No, it's not. I just showed you what it was, dude. Dude, I just showed you what it was.
I'm telling you right now. I'm reading off the paper. Okay, the K in the constant is the big number is equal to 9 by 10 to the power of 9 Newton in meters. Okay, the K constant in Coulomb's law is Newton's equation or Newton's
Those are the
constant.
two values, man. They're not in any way the same whatsoever.
So you're conjuring a magical force with your gravity formula when Coulomb's law is looking at natural forces, which electromagnetism is a natural repulsion and attraction force here on Earth.
This is crazy. They're arguing this.
Let me help you out, Dad. Let me help you out a second. So, Kosho, the point is Cavendish didn't exclude for electrostatics, right? So we could say that Cavendish actually showed us exactly the constant that Coulomb's law showed us anyway.
But you can't because
we could assert it. I could assert it. Speculation. I could assert it.
Yeah, the properties that he used were masses. If he measured the charge instead, then he could say, okay, well, these are the charges that would attract these things together. And what he would end up finding is that they would give him a wildly different value for wildly different things. And he would realize it's not.
You're misinterpreting the data of what the value is. You're misinterpreting the value of what that is. Like you're saying that the two constants are different when you're not understanding what the numbers mean.
Yeah, the two numbers are related to the two numbers. One is related to the charge that's multiplied. I mean, one is multiplied by the charge, and one's multiplied by the masses multiplied together. So you end up with three values multiplied together.
Yeah, but one's a reification of an.
Hold on.
Reification of an imaginary force. The other's a real thing that occurs, and one thing that we can.
Hold on. No, this is not imaginary. These are real tests that happen. Hold on, because you guys said a lot of stuff.
Gravity's imaginary.
Yeah, but what happens in this test is you multiply one mass by another mass by that constant, the g, and you divide it by the distance. You get a value, and this thing you can test with other masses and other distances. You then do this same test with one object in its charge, another object in its charge, multiplied by that k constant, and divide it by the distance between them. And you're not going to get the same value as the other. You're not going to get the same value that you got for the force.
It'll never be the same. It'll never be the same.
Because it's not the same thing. You're measuring two different things. I agree.
Cavendish did not measure electrostatic forces at all. None of it is his calculations. It's imaginary.
That's right. Because he's not moved.
You'll never get the same result day to day. The experimental change.
No, you get the same result from the Cavendish. You get the same big G every time from using different masses.
No, you don't.
Yeah, you do.
So every time
today is within 1% of what Cavendish got back then.
Okay, so you're saying that when you say Cavendish, you're also saying Cavendish experiments of today?
Yeah.
Then who are those people that done it? today.
I'll post this paper for the 15th time.
What's a stronger force, electromagnetism
hold
or
on,
gravity?
I'm getting to a point that goes with the topic.
10 to the 29th or 28th power stronger.
It depends on the scales that you're talking about.
No, all these experiments that the Cavendish did he do them within water? Did he do them within? Hold on. Did he do them within different mediums, just to see if he could extrapolate the force that caused it?
Well, that was my whole point anyway, when I started off and said that you cannot exclude for electrostatics, and until someone shows me the Cavendish so-called experiment where he actually shows, because you cannot, like I said, you cannot negate for electrostatics, meaning that the first law of thermodynamics is that you cannot destroy energy, it can only be transferred. I need to be shown the apparatus in which the electrostatic charge was transferred therein from the original mass. I want it measured in the mass, how much it is. I want to show that it transferred to a different piece of apparatus, and then me to see that the value of the electrostatic charge is the same in the other thing that he transferred it to, then have that thing taken out of the equation, so therefore I can see that the attraction has nothing to do therein of that. But I've never been shown this.
Well said, man. Very well said.
Thanks, bro.
Well, we got Chemo working on Biodual to get us a Cavendish in a vacuum. However, I told Chemo there's other variables that it's not being accounted for. He's not worried about it.
Well, again, as we said, we cannot create a perfect vacuum. So therefore, a perfect vacuum doesn't exist. It already is still then a medium because it can propagate light. It can propagate other things. It still isn't a fucking privation of gas. It's a near privation of gas. So therefore, in and of itself, it could still have electrostatics or magnetics in charge involved in. I need to see the very masses have their charges shown, tested, then the apparatus itself that is transferred to, because you cannot negate or destroy it, first law of thermodynamics, then show me that apparatus that it has in it removed from the equation, so then I can at least look at that.
So hold on a second. This goes back to what I was saying earlier.
Damn it. Hold on a second.
Somebody's
go
roboting.
ahead, left lane.
Yeah, I mean, what if you get the same values in the vacuum as you do in a shop? Would that negate any other variables?
Well, I told Chemo he's better.
It would give you a different result because you've changed the medium.
But what if you don't get a different result?
You will get a different result.
No, you won't.
The only way they can claim things fall. The only way they can claim things fall at the same rate on Earth is in the medium of a vacuum. Now they'll claim that it's not a medium, but they actually created the medium.
Right, so let me just comment on that. Let me clear that up for anybody. Wait there, let me just clear up what he just said. You would have to get a different result even by the idea of gravity being the cause of the effect, because they're saying that gravity itself,
exactly.
The full rate of the uniform fall rate of 9.8 meters per second or 9.8 meters per second squared, it is down to air resistance or wind resistance in and of itself that affects said fall rate. So even if you do it in a vacuum, right, which isn't a complete privation of gas, right, or something that cannot propagate, i.e. light or whatever, there isn't a full privation, it isn't something, it still has a
it'll
resistance
propagate
factor.
Light.
But no, but I'm saying
that's why it's a medium.
That's why it's a medium. But I'm saying that, listen, this is my point. It would have to have a different result because even in their own equations, right, with the gravitational constant, again, gravity there being not a force, in my opinion, due to the fact that it is affected by resistance, right, because a force would force past resistance.
Yeah,
anyway,
exactly.
The point is it would have to have a different result because even they're even admitting that gravity or this uniform rate is affected by resistance. So even if we put it into a vacuum, yes, it has zero or near to zero resistance. There's still some there. So the result cannot be the same, because you could then say, well, the result was the same, so therefore the cause of the effect was gravity. Well, no, we can't say that because there's still some resistance, so the result needs to be different.
Thanks. So the paper that I posted, I've read
the very fact that they have to wear astronaut suits lets you know
that's a good point, man.
They're in a medium.
Talking. Maybe
they're in a medium.
Yeah, James keeps talking over everybody.
No, I don't. I've
The fact
talked.
that wearing spacesuits.
Hold on a second, man. I listened to this show the whole way from home from work, right? I hear the same people that are still. I hear the same people. I've talked far less than anybody, and yeah, I'm the one that's talked the most.
That's all well and good, but Kosho started saying something, and then you interrupted him. So I'm just being fair.
Yeah, I've heard interruption after interruption, but I'll digress.
Doesn't mean you should do it too, man.
Yeah, if people wear spacesuits in vacuum. People wear spacesuits in vacuum chambers. Then that shows they're in a medium. Even though it's not true, your point is it's a good point. But yeah, I read the paper that I was posting, and they describe at least 10 times that they eliminate the electrostatic, any kind of electrostatic interference between any of the particles or anything in there.
But how did they do it? How did they
Describes
do
it in the paper. Yeah.
No, it doesn't. It describe it.
It does describe it. I promise.
So they measured the electrostatic charge inside the masses. They then transferred it to some other form of apparatus, and they removed the apparatus completely from the.
No, the only way they can do it is measure the charge and then present an opposite to cancel the charge out, which is not in the paper.
Which you can't do because of the first law of thermodynamics, because you can't
I'll read this part to you right now.
Destroy.
Right. It says, in addition to the seismic and acoustic effects, these are predominantly electromagnetic interactions. We ground the source by directly connecting it to the vacuum chamber, and this the test mass is discharged to less than 8 times 10.
So wait, you have to
elementary charges using ionized nitrogen,
right?
a method that was developed for charge mitigation and interferometric gravitational wave detections.
Cavendish did this.
Oh, not Cavendish. This is a modern day Cavendish test using an object in a vacuum chamber. Yeah, this is the same thing as a Cavendish test, just in a vacuum chamber with an even smaller mass.
So Cavendish didn't do any of that, right? But
he did something similar, but I don't know why we're talking about Cavendish's when I'm showing you one that is done today. What is the point of bringing up his?
He watched from a distance through a telescope, bro.
And it took him a whole summer to set that up because he was eliminating things like electrostatic charge.
He didn't account for pressure differentials. He didn't account for static electric charge. None of it.
He did. This is why he was so far away from it. And it doesn't matter. Talking about the way Cavendish did his doesn't matter when I'm showing you someone did it 2 weeks ago.
With the same supposition, right?
Yeah.
The thing you just claimed could be a problem was addressed in this paper.
So if it was addressed and if it was done differently, there should be different results than Cavendish because Cavendish didn't adjust for it, right?
Yeah.
No, it shouldn't be addressed. It shouldn't give you different results because that wasn't.
Wait a second. He didn't have the same parameters as the current test 2 weeks ago, but the results are the same. Is that what you're telling me?
Yeah, the guy manipulated
the parameters are the same. No, listen. You guys are claiming that the cause is something different.
No, wait. Then you're gonna have to say that the K constant doesn't even exist because the K constant shows propulsion. It shows right attraction and propulsion from one another, right? Using electromagnetism, right?
Yeah, but based on the charge those objects
wait there. Let me finish, please. But Cavendish didn't exclude therein of this exact thing as a value, right? As something that's going to be affecting the cause of the effect.
I understand.
But the point is now it's being extrapolated and exchanged and changed, should I say, it being negated, the electrostatic charge, but we're getting the same result. So this variable, right, which we know would have an effect, somehow doesn't change the results between these two tests.
Okay,
well, that would then have to be that K's constant doesn't even exist. You're not saying that, are you?
I understood that probably a minute ago. You didn't have to say the whole thing. But yeah.
Sorry, I'm trying to be clear for everyone else that doesn't have your same level of understanding.
No, not at all. So in one example, it's the mass and the other mass and the distance between them that is giving this effect. In the other example, it's the charge between them and that constant and the distance between them. In the example where it's mass attracting mass in Cavendish, you need to multiply their charges by each other. So you got to determine what the charge of these objects are. If they're grounded and they're giant masses, it doesn't matter. The electrostatic charge is not going to make a difference in that equation. You're not going to need to do that equation to subtract it from the other one.
Coulomb didn't.
It's got next to no charge. And we're talking about an extremely heavy object. In this example, it's a very small mass that's that could be affected by electrostatic charge. So there's taking the careful consideration to take that away from the system and do a test, knowing that that's not an issue.
Sorry, dude.
The instrument that Cavendish used, right? He could have used two different balanced balls, right? We know how he loves balls. And the heavier one, right? The smaller one, because his
has a different gravitational well, right? Oh, damn it. I'm disconnected, haven't I?
Are you there?
I didn't think there
You're
was
still
any
here,
gravitational
James,
wells on
saying
Earth.
something totally left field. And
I thought there's no gravitational wells here on Earth.
This is what I mean. I thought the gravitational well was the emergent gravitational well of the actual Earth itself via obviously the pushing down on the fabric in space, right?
I was told by physics there is no gravity well here on Earth.
Same.
Before the gravitational well, there was the gravitational aqueduct.
Yeah, this paper expresses a mass that's 2 millimeters big and shows that it itself creates a gravitational attraction. So there certainly is this is indeed evidence that gravity works on an even smaller scale than just the Earth.
A weaker force than electromagnetism. Yep. Okay, bud.
It depends on what scale you're talking about. There's certain scales where gravity is much stronger than electromagnetism. So,
in Cavendish?
No, not in Cavendish. I said there's scales.
So the electromagnetism force would be stronger in the Cavendish experiment than gravity itself, right? Because you just said the K constant is a stronger constant than the G constant.
No, I said it's
right?
a bigger constant. It's also multiplied by two other numbers. In one case, the charges of the objects. In the other case, the masses.
Right.
So that
which
number
is
is going to give you the
is
that
what
number
we
divided by
actually
the
have
distance
in
between the
reality, though,
force.
right? Which we actually have in reality, right?
Yeah.
Oh, that happens. This is done in reality. Yeah.
So we have electromagnetic forces that are stronger than gravity, but you say that gravity can be stronger in other circumstances.
No, in other
I'm talking
scales,
about
yeah.
I'm talking about Cavendish. The electromagnetic force is stronger in the Cavendish experiment.
Yeah, let's talk
It
about
depends-
the
it depends-
circumstances in which we're talking about. The circumstances in which we're talking about. Let's use. What do you mean? No.
No,
Yeah.
I'm not saying that it's and then Cavendish. If you have two large masses, like Cavendish used big large masses, and you ground them, you can make it so the electrostatic force is not present or next to not.
So in
there,
the
and
apparatus,
that's not going to be enough.
Cavendish didn't
It'll
do
never
that.
be enough to
Cavendish never
move the inertia.
grounded. There's no grounding mechanism in Cavendish's observation,
He
bro.
never done.
I believe
that.
there was.
He never ever. No, he didn't do it because you
Dude,
guys
there was
admit
none
he
of
didn't
it.
exclude for
It's not even in,
electrostatics.
it's not even
Or
in your
electromagnetism.
formulation, you moron.
I believe he did actually ground the objects.
No, it's not in your
No.
equations.
He took
There's
two,
none
it took
of it
him
in
2
your
months.
equations.
Yeah, it took him a whole summer to prepare the whole thing because he kept on.
Come on.
They kept getting variables.
Who
that kept getting
cares how
away.
long it took him? He never accounted for electrostatics or electromagnetism. None of it. It's not in the formulation at all.
I don't know why it would be in the formulation, but it
Because
certainly
you would
could be in its
account for it.
preparation.
You would account for it. And you would measure for it, and then you would either neutralize it to get an accurate reading for gravity. You'd want to separate the forces to distinguish the difference between them. And there's no distinguishing difference in the equation for Cavendish.
Yeah, it says right here.
Grounding it.
It says right here. in his
Just tell me the
experimental
formula.
setup,
Just show me the formula. Just
It's,
show it to
there,
me.
it wouldn't need to be in the formula, but it says in his setup, Cavendish did not measure electrostatic force. He simply confirmed
There you go.
the lack of it. Yeah.
So
He confirmed
confirming the lack of it and not measuring for it is not a pretty accurate test now, is it?
How did
Yeah,
you
it's
confirm the
not-
lack of it without measuring
If
it?
it's not measured, it's not going to get in the
Exactly.
way.
So, but it got in the way with Coulomb's test, right? Coulomb measured for it. He
No,
accounted for it, right?
He was trying to measure it.
So what Coulomb did, what Coulomb
Wait
did
there,
is he accounted.
Let me just say this. You have to then deny what Coulomb did completely because you're saying that there's the people that did negate for electrostatics and electromagnetism in the Cavendish observation now are receiving the same results as Cavendish, even though they didn't exactly change. Like I said, the
Let me read it
tolerances
again. It did say
therein. You know
it says
this
he
is
did
true,
measure
Kosho.
it. He didn't
Right,
measure
so
it.
if you,
Yeah, but hold on, because you're
Kosho.
totally misinterpreting
But
what I
the
just
people
said.
How does he know it's not there without
listen.
measuring it?
Listen. The people that excluded for it, though, right? He might not have
For
measured it, but they didn't. He didn't exclude for it.
Yes, he
The people
did. I
that
just
did-
read that he did.
How does he know it's not there without checking it?
He confirmed that it was not there.
How? Without
he
checking
didn't know
it?
about it. He didn't know that.
He didn't make a measurement. He didn't make a measurement to see how much was there. He made sure that he could get rid of it.
How?
Talking at both sides of your mouth. How did he get rid of it? He didn't even know it was there.
No, he did not. He doesn't say he didn't know it was there.
How, Kosho? How? Without checking it, how did he get rid of it?
I'm sure he used a tool. It doesn't say. What do you I mean? Why would I know how he did it if it's not part of his formulation?
No sense. Then you just
You're
made
defending
that
it
up
right
then,
now.
because how do you
Yeah,
know?
because I'm reading that it says that he, in his preparation, he did not measure it, but he did make sure it wasn't there.
Okay, you're reasserting the claim. We want substantiation. How did he make sure it wasn't there without checking it?
You're gonna have to look that up, or I'm gonna have to look it up.
Okay.
Yeah, you look it up, buddy, because you seem to have. You seem
This
to
is my whole point from the beginning, is that you would need to show me the apparatus in which, because of the first law of thermodynamics of transfer of energy, not destroy, it's why we cannot negate for it, we need to see the apparatus in which the energy, the electrostatic or the electromagnetic charge was transferred thereinto and then removed altogether from the scenario, right?
Okay. Can you describe to me the charge an object would need to have to move an object the size of the objects he used, to move the inertia of the object, the resistance from accelerating? You need to have what charge would you need to move an object like that?
Well, look at
it's not going to be some ambient charge. It's going to be some strong.
Have you looked at the charges inside the coulombs?
Yeah. What do you mean? The charges in his formula?
Yeah.
Yeah. You multiply them together. Yeah.
Well, there you go. Those did he not do exactly
No,
what
but
you
I'm saying,
spoke of?
What I'm asking you is, do you know what charge he would need to have to multiply to the charge of the other thing in order to get the same exact force as what's gotten into the universal law of gravitation?
The point
because
is
it's a much different, number, and
that's what you're saying, but that's not what we're saying. We're not agreeing. Me and you are in disagreement on that, then, aren't we? And so
how is it the case that this test got the same value Cavendish got?
You're just misreading it.
The formula for
gravitation. You're not reading it the same way as me. Maybe I don't know. Maybe we need to have a little power on that sometime, because otherwise we're just going to keep talking about it.
The way that this guy did it and the way that Cavendish did it is they used the masses of the objects to get their value, and they used this constant, or they got this constant. That's how they got the force. If it was any reason it was the static charge that was doing it, they would disregard the masses in both cases and transfer it with the charge of these objects, and they would have to have been the same charge for some reason. The objects in this vacuum chamber that were devoid of charge and the objects that were used in the Cavendish experiment, it doesn't make sense that they would get the same value.
Yeah, because you're conflating cause and effect again.
No, it's not because of conflating cause and effect. I'm using the masses and big G. I mean, that's it. The only thing that they have.
So if they set up the same premise, didn't account for the same things, and then you're asking me why they have the same results?
They did account for the same things, indeed.
So they accounted for electrostatic forces. They neutralized it out. That's what you're
exactly
saying. The same masses. They watched it from a telescope in another building across the street, right?
It says right here that I made sure it wasn't there. Yeah.
Yeah. Dude, at the end of the day, Coulomb's law beat Cavendish at it with actual natural elements. And even Einstein was thinking in his head, electromagnetic forces is stronger than gravity way before this fucking bendy space-time shit.
10 to the 29th power, 10 to the 28th power. Stronger.
Yeah, in some circumstances, that's assuming that the masses is the exact same thing as the charge. But when you have very different masses, large masses,
you keep saying masses in a non-applicable
and you have
way.
charges that are not in any way comparable, you end up with things that are where gravity is much stronger than electrostatics in that situation, like a black hole, for example, a neutron star.
Did you just
A
say
flipping black hole is exactly.
We just turned into absolute fairy tale bullshit now.
You know better than that, dude. This is like me saying,
You were borderline
if you
before.
want to go there, dude, then the whole reason you exist and the whole reason
Dude, I'm not
right now is a theater.
Just because
Kosho, you keep explaining mass as
dude,
you keep explaining mass as something bigger than the other object.
Let me just get this in.
A rock that can fit in your
That's what she
hand.
said.
can have more mass than something 100
Just
times
because you
its
guys don't
size.
believe in something doesn't mean I have to negate it
Well,
from.
dude,
my
listen,
argument.
wait there. So then you must believe then, Kosho, in Athea, the wayward planet, right? That gave you the ability
you
to
must be
breathe right
talking
now.
about
That gave you the gravity that you're talking about. Because
it's not-
without Athea, the wayward planet, you would obviously not exist, right?
That's a hypothesis. I mean, that's a
Well, no, it's something that's needed in your own evolutionary story of the Earth, the evolved
that's a
of the Earth
hypothesis for the
itself.
creation of the moon.
Huh?
It's a hypothesis for the creation of the moon.
It's not just a
It's not a
hypothesis for
valid-
the creation of the moon. No, because we have the exact chronological order, right? In chronological order, right? And then we have the timeline therein of which the Earth's old core would have burnt out based on different variant tangent points of the narrative itself. We know the Earth's molten core would have burnt out 4 billion years ago if it was not for the very thing that crashed into the Earth that caused the coalescence of the debris into the thing that is the moon itself, which allowed for us to have the exact size to fucking distance ratio to the sun for us to be able to experience fucking eclipses. So you know
that's not
yourself.
and that is only a hypothesis. It's not.
It might be a hypothesis, but it's a hypothesis that you need for your whole fairy tale to exist. Yeah,
It's not a valid.
It's not a hypothesis.
It's not a.
If he thinks the Cavendish is an experiment, then he doesn't know what a hypothesis is.
This is only a hypothesis. I swear to you, it is. There's no way.
The Cavendish has no naturally observed phenomenon.
That's fantastic. I'm talking to this guy. I'm
earlier.
talking to this guy about the moon.
Still
okay?
waiting on it.
That's fine, man.
Yeah, you're not.
This is only a hypothesis.
No, Kosho. I'm not talking about it for the moon. I'm not talking about Athea, the wayward planet, in relation or conjunction with the moon. I'm talking about this in relation to the fact that the Earth's core is still burning hot enough that you can have your electromagnetic field, right? Because you need something to interact with the Earth 4 billion years ago, based upon what we know to do with Earth sciences that tell us that the Earth's core would have burnt out at that point, meaning, i.e., Athea also deposited its molten iron core, which now allows you, in order for you to have your so-called gravity as it is right and now, as it stands.
That's why it's a hypothesis.
But you need that hypothesis to be true. You need that hypothesis to be true, right?
No, you don't need it to be true. No. The answer is no. No.
Give me the opposite hypothesis.
If that amount of iron and nickel was already there, then you wouldn't need the hypothesis to be true. The hypothesis probably is true. I agree with the hypothesis, but there's no way to prove it. There's an idea of how it could have happened.
Who do you need to disagree with? For that hypothesis, what you call a hypothesis, for that hypothesis to not be something you need to agree with, who is it that you need to disagree with, right? Based on how much nickel and iron there is in the core, you need to disagree with certain individuals right now, right? You need to call them liars, okay?
I already said that I agree with that hypothesis, but it's in no way been proven. I just said that, dude. I agree with the hypothesis. That doesn't make it not a hypothesis.
You believe in fairy tales, dude.
No, it's like string theory. String theory is just a hypothesis.
Crackvillain just made a good point.
It's not been tested or anything like that.
Listen, I just made a brilliant. Yeah, wait there. Who was saying that? I made a good point. You can talk.
Hold on. Let me say this, man. Let me get. Here's the point I got out of what Crackvillain just said that most people wouldn't have, right? 99.9% of people that believe they're on a globe don't even know who Cavendish is.
Yep.
It's only a handful of people that are arguing on behalf of the globe. The rest of them just believe it.
No,
my question is, why is that?
Anybody that's taken a physics class in college has probably done something similar.
But you have to take a physics class. You got to be in with the cult.
Oh, so educated now cult.
And then again, listen,
well, indoctrinated is
cult. What else you should have got from that? What else you should have got from that is that it's also an even lesser number that know that you would have to agree with the so-called hypothesis as Kosher likes to outline it as, right?
No. You'd be able to observe it naturally. People would be able to. They wouldn't have to rely on authority or a college degree, which college is just a business.
Of course.
And people that want the 3 letters after their name, they're just applying to the business.
But my point is that Kosho is a very small number of people that understand what you would call a hypothesis, right? A theory of the wayward planet, right? That whole thing, right? It's not a big number of people that understand that the globe relies upon this historical story that 4.4 billion years ago, right? Where a theory of the wayward planet in a glancing blow that somehow was not glancing, because if it was glancing, it wouldn't have had its Monroe effect, i.e. this inverted copper cone like type effect that you have in RPG is shape charge, right, where it bores its own molten iron core into ours, replenishing it, right, in order that we can have the electromagnetic field as we understand it, in order that we have the gravity as we understand it, in order that we have an atmosphere that exists here. This is a very small number of people that understand what that is and what that means and how important it is to the idea that the globe itself exists in the current state it exists in, which is the state, in fact, that allows you to breathe, right?
Yeah, that's if the hypothesis is true. That's if the hypothesis is true. If the hypothesis is true, then that event happening is why the other things, the magnetic field is possible, why our crust is small and our core has so much iron and nickel. If that hypothesis is true, then that's true. If it's not true, then you have nothing to think or anything like that.
The globe model's dead, right? The globe model's dead, right?
The globe. First of all, I don't understand why you guys think science works that way. The way science works is you find evidence, and those evidence lead you to conclusions. And those conclusions can be tested.
But what's the conclusion therein if that narrative isn't true? What's the conclusion?
Then our planet formed in a different way. The moon, we obtained the moon in a different way. I mean, that doesn't mean that's not a globe. But the people that said that narrative and outlined that narrative, right? Then that would mean that they were false in their actual. Yes, that would mean that the people who came up with the hypothesis were wrong. That's right.
Right. And who reified lots of the ideals based on that narrative?
First of all, and none of the things you talked about after that are dependent on that narrative. They're dependent on that thing happening.
No. I understand that.
I know, but that's what I'm saying. Nobody's deciding there's no sciences or something that's dependent on that narrative. That's just.
There are science. There are people that have made scientific hypotheses, right? So-called after the fact, based on the event, right? Meaning that there are people in astronomy, there are people in theoretical astrophysics, that need said narrative to be true in order for their own scientific hypothesis to be true, because they started off with that faulty premise.
Yeah, like who? What conclusion? What? Give me an example of somebody.
Whether for one, let's say
anybody is based off the foundation.
Wait, let me ask. Crack villain.
Right. So anybody that has spoken since on the same. So anybody in theoretical space physics, right, that has spoken on the same chronological or timeline that includes the creation of the Earth in that timeline, meaning that anybody that has first used as a foundationary point that the Earth being a certain age and the Earth's decay rate of its core and it burning out, right? Anybody that's in line with that narrative right there, okay? Anybody that has basically stated from now, right, going back to the 60s to now, right? Anybody who has used that as their foundation, that the Earth's core would have burnt out, to it being replenished by a theory of the wayward planet, people that has used that as their foundational point would have to then show that a lot of their workings were incorrect. I can't name them all off the top of the.
It took you a long time to say that, man. No, they don't. No.
Oh, are you going to just comment on how long it takes me to say things as opposed to the content of what I say?
Well, yeah, you're saying the people that but you're saying the same thing. You're saying the same thing again and again. I'm just saying that the.
Well, I'm asking you as well. I'm asking you. I'm
saying that's not true.
Maybe not.
It's not true.
Is that not true?
Because all you need to know to come to the conclusions that you're talking about is the contents of the Earth and the core and stuff like that. The question of how it got there is not going to change their hypothesis. Like let's say their hypothesis based on. Let's say the hypothesis their hypothesis has to do with like what you said, that the core should have burnt out. That would be a possible solution for how it lasted so long and why there's so much iron.
Wouldn't that then cause
if the iron and nickel got there from a different cause, because maybe it was say again?
From a different source.
If it got there from a different cause, like it collected together beforehand, That's possible too.
Right, so then it would actually call into question the people that that asserted the very timeline in which these things occurred, right? Because they're saying that the Earth, let's say, coalesced together at this time with this amount of nickel and iron in its core, right? That would call into question their so-called hypothesis, would it not? Because obviously then that would mean that it was false what they said about how much iron and nickel was there. It would call into question many seismologists and geologists as well. This is
because that data is not determined
yeah, because
by
they were incorrect. It meant that there was a different methodology. No, it would mean they're incorrect. The end point, you're correct. The end point, right? Listen, let me finish. The end point, like you said, the fact is it either exists as it does or it doesn't. The Earth either has a core or it doesn't. But the people that hypothesized that the Earth's core was going to melt out or burn out, right? And it did coalesce together with not enough iron and nickel to continue to exist without an event of replenishment. Those people that agreed upon the idea that it would need a replenishment, right? Their timeline of how long the Earth it took to form and then when it formed and how much properties it had, or should I say products, or should I say elements therein in the core, those people would be incorrect on their story of how it coalesced together, correct?
No, because they're geometric. Dude, I'm not gonna take nearly as long, so fucking don't interrupt me as soon as I start. Whoever's doing that, but the what do you call it? The dating methods. Yeah, so the dating methods that are used to date rocks. I forget what it's called, but yeah, the dating methods that are used to date rocks.
You're taking too long.
Dating methods that are used to date rocks are not going to be any different than they were in either case, and neither is the seismology that's used to determine what's in the core.
But you don't even know what the dating method is.
Timeline.
Yeah, listen, this is taking you too long, dude. This is taking too long.
Change due to the
the dating methods don't change. But you don't know what it is.
20 seconds.
Listen, you want to talk about how long it took me to say something. You didn't say a single thing of value within the first 30 seconds.
I did. I addressed your whole points in 20 seconds. I said that both the dating methods,
carbon dating,
the dating methods that date the Earth,
you spoke about dating methods when I spoke about the narrative.
You don't even know what the dating methods are, man. It's called carbon dating.
Yeah, I'm not talking about carbon dating, genius.
I wasn't talking about anything to do with. I wasn't. Listen. I wasn't about the people that drew out the narrative of the actual Earth itself and its formation, and the people that hypothesized how many elements or how much of the elements were therein inside the core. I was saying I'm on about theoretical space physics, not geology. I'm saying what they said their narrative would have to be untrue if said event didn't happen and there was a different methodology in which the Earth was formed into this ball. Right? They would have to be untrue, is what I'm trying to say.
Yeah, I know. The people you're saying the people who came up with this hypothesis would be wrong if this hypothesis was wrong. Yes, that's true. But that doesn't change anything. That doesn't change. The people
hold on, Kosho. Your argument was the dating of rocks.
Radiometric dating.
Specifically said, I don't know what the method is.
I said I forget what it's called. Dating. I said something dating.
Their method of dating.
Absolute dating.
You don't know what it is, but their method of dating.
Jesus
Christ,
Christ,
those are words that came out of your mouth.
I try so hard not to call you dumb this whole time, but you say some of the dumbest shit. Okay? Obviously, I know.
I'll just call it out, man. You're the one that said. You're the one that literally said. I don't know what the method is called.
No, I didn't. Yeah, I didn't say I don't know what it's called.
The method of dating,
I said I forget
like rocks and things.
God, you pick like the most wrong things to focus on.
Yeah, but Kosho, the only reason they're focusing on that is because keep on concern trolling about how long it takes me to maybe explain something. So they're saying that you're sort of being a little bit of a hypocrite when you say things like that after telling me I'm taking too long to explain my premise. That's why they're saying it, bro.
I'm not saying so. I'm not saying it in order to find an insult with you. I'm saying it because I wish that you would just condense what you're saying down to.
I'm sorry. I'm not that brilliant. Sorry, I'm not better at what I do. I'm so sorry. I can't.
No, it's not about being brilliant. I'm just saying you said you used a lot of words to say the same thing, and
I'm lucky. I can't help it. That's just the way I talk sometimes. Like I said, I'm sorry. I can't help it.
It's fine. I'm just asking you if you could make it concise. That's all. If we all make it concise, and we never.
There's a guy that debunked carbon dating. His name, and this is where I shouldn't bring this up. His name, I can't remember, is the name of the debunking of carbon dating.
So wow, I can't believe you don't know his name. You don't know anything about it then.
Yeah, I know. It's my own it's like I'm turned into a glober right now.
The funny thing is you actually really don't know anything about it because we're not talking about
carbon dating. This is what you do. Carbon dating, a dude buried he drew Hebrew on a stone tablet that he made with concrete and certain rocks and other different.
Dude, is his name Barry or Drew?
He sketches Hebrew in it, buries it for 7 years, digs it up, and claims he found something 1,000 years old. And for about 6-7 years, he got away with it.
We're not talking about carbon dating. We're not talking about carbon dating.
So all I'm saying is, when you have a method of dating, it's still the method of the time. And sooner or later,
about carbon dating. Carbon dating has things that you can run into flaws.
My method of dating: never take her to a restaurant. Always take her to a bar for drinks. And then smash on the first date.
He's not saying here we are talking about carbon dating. What he's saying is that if there is an issue therein of carbon dating in and of itself, and this guy debunked it, right? Yeah. No. He's saying that. All right, so say no before I'm finished again. This is why it's hard to be concise.
The flaws with carbon dating are not relevant to the flaw.
I know they're not. I wasn't. That's what I was explaining. This is what I mean. I was literally explaining how he isn't talking about the relevance to carbon dating to the current conversation that's going on. He was simply stating that in the same way currently that we're talking about with the dating of the Earth and the dating of the Earth's coalescence into a ball and the properties of the ball itself and how many elements it had in its core. He was saying that the very things that came before carbon dating and carbon dating being the thing used to date things, if the very method is wrong, then many of the things before it and the hypotheses before it are also incorrect. Right? That's all he was sort of saying. It was more of to elucidate a point, as it were.
But then that point's also irrelevant because carbon dating as a method is not invalid. It's just people can get flawed data.
It is invalid.
It's not invalid, but you can get flawed data and come up with the wrong conclusions.
Ice cores.
In this case, though, we're not talking about a method. We're talking about a hypothesis.
Controversy.
And the hypothesis being wrong.
The ice cores from the Antarctic are in controversy of carbon dating. If you keep up with real science, well, I don't even call it real science, so I apologize for saying that. If you keep up with what they call real science, ice cores from the Antarctic are in controversy with carbon dating.
Hold on. I don't think that's carbon dating, right?
It is carbon dating.
They just assumed that each thing was from a year.
In the air, right? They're finding.
No, I thought it was from winter cycles for that one.
Well, they're proving the climate change wrong, right? So they claim there used to be an ice age. This was even the melting of that ice, the melting of it was far before the industrial age, right? So there's a massive amount of climate change. They claimed it came all the way to North America, clear into the Mid-South, right into the middle of America.
James, I'm sorry for calling you dumb before.
They claimed all this ice, and they can claim it by how it came in and receded and scarred the rock. The ice put scars in the rock.
I apologize for calling you dumb before, but
what I'm getting at is
your
the climate change that it took to before the industrial age to melt all that ice.
So man has no effect on the climate
today's
whatsoever.
Climate change.
Is that what you're suggesting, James? Man has no effect.
I'm suggesting that even if what they're saying is true, man will never conquer climate change.
Really? Man doesn't have an effect
You'll
on
never
its
conquer
environment.
it. You can't stop ice.
No, the Earth is way
They're
too
the ones that
massive.
claimed ice came. You can't stop ice.
That's a head in the sand approach.
It's a powerful force. Ice will
You
expand
cannot
metal.
control the weather unless you purposely spray the skies and do seeding. But as far as changing as far as changing the overall seasonal pattern and claiming that we are causing
to a whole
the
bunch
climate
of points.
change,
Somebody got my previous point, and I'm extrapolating on it with a different science.
Anymore.
All I'm saying is carbon dating, climate change, these are all based off authority.
Fighting over climate change is a good way to ignore
all you want.
Is fucking exactly where it lives.
Yo, technically, since we're all carbon life forms, if I date a girl, it's carbon dating.
That's true. I made a dating app called Carbon Dating, actually, but that's not important either. It is important.
If you have never carbon dated anything,
all biological life.
You've never carbon dated anything, then you're appealing to authority.
Continue. It's like it's 5 books in one. Radio. What was saying? Oh yeah.
Your point on this, Kosho. I get your point. I think he was trying to elucidate a point. I don't think he was claiming it was to do with that. That's all I'm saying.
Is it fine? Okay. Well. Anyways, but all biological life has influence on the atmosphere and the weather and all that kind of stuff, and the climate and all that kind of stuff. They have an effect on it, and they have an influence on it. And so
appeal to authority, dude.
It's not appeal to authority. That's appeal to. That's what happens, man. That's all biological life.
You totally exposed yourself.
On the atmosphere. This is true.
It's not like my discernment or nothing. You've exposed yourself.
Okay, so
you
in your opinion, James, in your opinion, James, do the plants on Earth have any effect on the atmosphere?
You appeal to authority, dude.
Do the plants on Earth have any effect in the atmosphere, James? The answer is yes. Does the breathing?
When you say atmosphere, that just backs up my claim.
Oh, wait a second. Plants have an effect on the atmosphere. So wait, thousands of years ago was hotter.
When you say atmosphere, you're
that's not what I'm saying. We influence the atmosphere. We influence the climate.
So we produce more carbon,
because you've seen it with your own science.
We produce more carbon, more plants grow. That's how the Earth.
Yeah, you've done your own experiments, and you agree with the authorities, right? With your experiments.
We have an effect on the environment that we live in. And saying that we don't have an effect on the environment that we live in, you're just a stone cold faced liar at the end of the day.
Well, I know that we have an effect on the environment,
exactly.
But I also know the environment.
What we do.
I also know that the environment has more of
whether you mean negative or positive effect.
So what you wear for the day, is it determined off the environment? Or what you wear determines what the environment does.
It's such great points, man. What the fuck does what you wear have to do with this conversation?
That's a fucking stupid point. What the fuck are you bringing up?
No, that ain't a stupid point.
It is a fucking stupid point.
You don't cause the environment, right?
Really?
You don't cause the weather.
Man has no effect on the environment
you're
whatsoever.
affected
You are so
by it.
full of shit. It's not even funny.
Yeah.
Well, wait there, guys. What we need to say is there could be a correlation, right, between man and the effect on the actual climate itself, right? But what we also need to understand is that the climate itself obviously had differing degrees of variation and change therein of said environment, right? Before man even apparently existed in the evolutionary timeline in which you guys prescribe yourself to. So, you know, this idea we affect the environment. Okay, cool. You could say that we do. You could also say that we you could say lots of different things affect the same thing, right? So it's not one or the other, right? So, like, again, we have to.
Yeah, you're saying that when I wear a t-shirt and shorts, that it's summertime because of what I'm wearing. I affect the environment.
No one's saying that. What we're saying
bring
is
it to such a pathetic level. It's not even funny, James. That's such a pathetic level to bring it to. It's not even funny.
Yeah. Well,
no, that's what they're saying.
James,
look, you don't affect the climate.
James, to be
the
clear,
climate affects us, and we adapt to it. It can change at any moment.
Algae, for example.
That's exactly what I'm saying.
No, James, I'm saying
what
you don't
hear me saying is what I'm saying.
No, we're not, James. So why don't you just listen for a second?
And you guys are trying to extrapolate some reasoning off of skyscrapers and massive amounts of concrete for roads.
James,
deforestation, all that
in
sort
which
of
it
stuff.
does.
Yep, 100%. 100%. There's a correlation with all that sort of stuff. What it does.
Yes, 100%. But what is it? What is it?
You, whenever algae, for example, which releases a lot of oxygen in the air, or plants that release oxygen in the air, and humans, which take in oxygen, and other animals, which take in oxygen and breathe out carbon, these cycles change the atmosphere. This is a fact, okay? And the same thing with when we burn fossil fuels that we got from under the ground and burn them in the atmosphere, this also changes the atmosphere. Everything that we're doing on massive scales like that is having some effect on the atmosphere. This is not in question.
Damn right it is, but nobody cares.
Hold up, Coach. How do you know
they
that
think
the
throwing
trees
money,
and like all, the ecosystem isn't accounting for it?
Type this into Google, guys. What does New York do with its trash?
That's fantastic.
If you type that in, and then you click videos,
built by the trash. It's not
your heart is gonna skip a beat.
No,
your heart will skip a beat when you see what New York does with its trash, right? But nobody cares about that. They want to claim the science. They want to be like, look at what we're doing to the environment, but yet the government doesn't want to change it. They just want more money from you. Like that's gonna solve it.
What the fuck has the government doing with its trash got to do with anything?
Exactly. You're not listening to the
Well, that's the experts.
Percentages are relevant to what we're saying, man. So why don't we just let a percentage ask this question again?
Those are the experts that are telling you that.
Okay, James, can you
Give
let
us
percentage
more
ask
money,
the question? It's
and we'll fix climate change.
You're saying a irrelevant thing after irrelevant thing. Can you let percentage ask this question again?
I was basically saying.
I'm saying the experts are telling you, the scientists,
please don't say
they're telling you that if you give them more money, they'll fix the climate change. What I'm saying is, if they're being honest and we really are doing what they're saying, that's a way of life, and we must change our way of life. Otherwise, it's not going to change no matter how much money you throw at it.
I'm going to ask percentage to ask the experts so we can have a conversation that goes back and forth. Like we're responding to things that other people say. So percentage, can you just ask your question again?
Yeah. So you said that we change the environment. Us as humans are changing the environment. And while I'll grant that we do affect the environment in one way or another, positively or negatively, how do you know we're changing it? Like we're changing it for real when the environment and like nature has a self-regulatory mechanisms?
Yeah, that question is not a bad question because it is involved in this, and the exchange, like the exchange of breathing between plants and animals seems like it can regulate itself, but the exchange of the fossil fuels that we get from under the ground, which we have one idea of where they come from. People can have whatever idea where they come from. The whole point is that it's something that we're introducing to the atmosphere. It wasn't a part of it's not part of any cycle, or at least any short-term cycle from before. And our idea of how it got there was from dead trees and shit like that. So, but regardless,
they're literally admitting that their science has progressed us through.
We're introducing it to the atmosphere. So we are going to have some effect on it that's going to be different than any effect that has been happening in the past, our lifetime or whatever, or the lifetime of humans or something.
Yeah, and again, how do you know that like we're changing the environment? How do you know that it's not within this buffer type of zone where the environment can can adapt to it?
Let's remember we had an ice age once and it melted all on its own without us.
It's just like what's released.
None of you guys did it. Obviously, none of you guys. None of you guys typed in.
James, shut the fuck
Hold on,
up.
you got.
No.
None of you guys typed in that shit.
Wait there, let him finish what he's about to say, James. 1 sec.
For fuck's sake, James, you've been talking for 3.5 hours.
Alright, cool. I've just got him to stop, so carry on.
Alright? It's not just what's released into the atmosphere. It's what's released into the waterways, what's released into landfill. It's everything. Alright? Concentrating on the wrong, it's everything that we do. Not just one thing. or a couple of things. It's everything. And if people can't see that what we do to our environment is wrong and has a negative effect, shame on you guys. Shame on you guys.
Well, I feel like the
I
Earth
agree
is
with
actually.
you, man.
I agree with that, but I feel like
you're
the Earth
missing
is
what I'm
probably.
saying.
Yeah, what are you saying? Carry on. Sorry, I didn't mean to speak over you.
I agree exactly with what he's saying. We are affecting our environment.
I just don't think we can.
When I told you earlier,
yeah.
When I told you earlier to type this into Google, what does New York City do with its trash? And then click videos, right? Your heart will literally skip a beat.
Okay, that you said this already, man.
Like if you do that right now, you'll know what I'm talking about.
Dude.
Right?
Do us all a favor.
So these scientists,
point.
They love all that trash. They love all that consumerism. They love the fact that.
What do I Google, James? Interested in being a part of this conversation?
Oh, yes, I am. I'm getting to it. I'm getting to it. What the hell, man?
Just get to it.
You don't understand what's going on. Like people in the debates. They don't really get the picture.
Again? I don't think we heard you.
The scientists won't tell you to do that. They won't tell you to type in what does New York City do with their trash. They won't tell you that.
No, man.
Because if you do, you'll quit consuming all this
people are leaving, man. Just
hold
make
on. All right, I got you. Hold on. Go ahead, Coach.
I mean, I don't want to not include it, but
everything's wrapped in plastic.
Okay, that's fine, man. But okay, so I don't remember even what the last thing the fucking people in the conversation were. Oh yeah, right, Bandsaw. What he said is correct. That we do have an effect, and I'm not even saying whether it's a positive or negative. I'm not saying that the climate change that what we're adding to the atmosphere is going to make it worse or better. I'm not saying anything like that. But you have to understand that if all life influences the Earth, then us humans, the ones who are the most capable of influencing anything, are indeed influencing the Earth the most than anything else and everything that we do. And the farming and then the shit that we build and stuff like that, and in producing oil.
I guess the question is life influencing the Earth, or is the Earth set on its own kind of course?
It's a dynamic system. It's a dynamic system that, for instance, let's pretend like our idea is right, and that a long time ago plants grew and then died, and there was nothing to decompose them because that life hadn't evolved yet. If this is true, then that will never happen again. So it's not. It wouldn't be a reoccurring cycle in that case. And my opinion very much might be true that oil that was created, the natural gas that was created, is not going to be created in the same way in the future. And when we use it, we're going to use it up for good, and we're going to add something to the atmosphere that hasn't been there in millions and millions of years.
Thank you for that.
What is this that you're posting, Paige, by the way?
It's a picture of some water on top of some land.
Can you tell me something about this picture that I couldn't figure out immediately? Paige, I understand that it's water on the land. By the way, Paige, I'm sorry for calling you mad earlier and calling you crazy. I was mad, and the other.
You're right. I'm used to it.
So I apologize. Okay?
Coach, I just want to
thank you, Coach. I appreciate
it. Despite all the wrong things you said tonight, Coach, you did a good job sticking through it.
I get frustrated just like everybody else, man. So I apologize for it.
No, just when that picture is not for any information that's on the picture. It's just to demonstrate how our minds, like when they created this picture, the guys who drew it or created it on the computer know. They know the water's flat. They know. So they draw it the way they know it, but It's only when we start talking about the ball, or, you know, with people who believe the ball, that's the only time we ever hear people say water's curving. And so all these kinds of diagrams will show flat water, because everyone knows deep down water is horizontal on top in large bodies at rest.
Yeah, Paige, you remember whenever we talked? Go ahead, Jeremy.
I was going to ask James if he's interested in having a one-on-one debate with someone.
One debate.
Yeah.
But regardless, and James, you can answer that if you want to answer it also. But Paige, I was going to ask you, or I was going to, yeah, right. I was going to ask you if you remember the conversation we had about simulation, and we talked about how it could be like let's say it was like a simulation, and you're walking around, and it's being created as you're interpreting it, same as a video game.
A first-person rendering, yeah.
Yeah, sure. Because I know in Grand Theft Auto, for example, it's got a big world, but the world doesn't exist there all the time. It only exists there as your person is moving.
As somebody's, walking towards it. Yeah.
And I've made games. I've made all types of games before. And when you make them, there would be no reason for me to make a surface. Like if I was making it Earth, for example, that I was staying in a local area or a state or something, I would just make, a bunch of flat pieces, like kind of like what you posted. Like that would be one platform, and you would just make everything on it, and then you would combine that with another level, but you wouldn't create them at the same time. You maybe would create them separately and then add them together at different times and stuff like that.
Yeah, well, that's what they say the ball's done. They say basically that you end up with like a disco ball. You've got little squares, those squares are actually flat, but then you put them all together and you can stick it around a ball. Right. Our problem with that is, well, if you're measuring all those squares flat, then where did you get the curve from?
That's the problem.
Why
Those
are
little
you even
squares
adding a
aren't
curve
measured.
in?
Yeah.
They're not measured flat. They appear flat with our shitty eyes, where they're measured with
No,
curves.
they're measured flat with Cartesian coordinates, a 3, X, Y, Z, elevation changes over horizontal datum. That's what they measure. Then they do spherical excess, they do calculations, and tell us we live on a ball. If it wasn't for NASA, like if NASA had never existed, people were still being taught they lived on a flat Earth at the start, 1900s. So it was only NASA making up that bullshit that's made everybody believe they're on a ball. In my opinion.
I don't think it was only NASA, but definitely the debate would be very much alive, as opposed to this 95-5 or whatever. It would be a 50-50 type thing, or even less.
I think it was 95-5, that 95% flat Earth. I mean, these newspaper articles are talking about burning people at the stake for trying to teach schools that Earth's a globe. Like we're talking about 1900.
I don't think that's true.
Yeah.
I don't think they burned anybody at the stake.
There's a lady who's alive now, given her testimony that in primary school they were taught the Earth was flat, and they changed it while she was in school.
I've seen David Weiss's video, but that's not the same as somebody being burnt for teaching it. And the truth is,
I said in the newspaper article, they talk about how heretical this doctrine is, and how we should never allow it to be put in our schools, and how these people, should be burned at the stake for this particular doctrine.
Right, but I think that was a satire paper. But regardless, it is true that somebody was actually burnt at the stake for teaching it was a globe. So that actually happened, but
no, not somebody.
What you're talking about is just a satire.
Not somebody. Multiple.
Yeah, somebody got burned.
I don't know about. Yeah, well.
I don't think any of that actually happened.
Protestants. If you study history, the Protestants They didn't believe the globe because of biblical reason, right? But today, the Protestants
I think that's what their
will
argument
tell you
was
it's a
in the
globe.
newspaper.
Go figure.
Yeah, see, I like that, man. That's James's quick, succinct point. And I love that. Was actually a really good, quick, succinct point. But what Paige said.
Hold on a second. Hold on.
Yeah, that was a satire. The Giordano Bruno guy was a guy who actually got burnt at the stake for teaching it was a globe.
Oh, the satire, like a parody?
No, the newspaper wasn't satire. It was a proper newspaper. They weren't saying they were going to do this or they had done it. They were just talking that kind of doctrine, because it's so bad, it's so wrong, that, it should be treated, people should be treated like that, because it's, such nonsense. That's what they thought, that it was just, absolute nonsense, which it is.
Two nations do not go to war because, well, hold on. Two nations do not go to war because one is telling the truth and the other is lying. They're both lying. That's why they go to war.
James, would you be interested in doing like a one-on-one kind of debate thing?
Who, me?
Yes, you, James.
No, nobody will do a one-on-one debate. That's non-existent in today's world.
What do you mean? Brandon just did one. So no, is that a no? It's fine if you don't want to. It's okay.
For who? With you?
No, I'm not going to do. We're on the same
I'll do
side.
a one-on-one debate with anybody.
All right.
With anybody.
I'll get you someone.
Even a flat earther.
Well, I'll get you a Glober to start off.
The only reality is the individual. That's my argument.
What does that mean?
I don't know, but I'll find you a Glober to get on there.
Nobody lives the same life. They claim there's 7.5 billion of us on the earth, and not one of us live the same life. Therefore, reality is based off the individual.
Does anybody disagree with you at that point?
Yeah, I think many people do. Mostly Globers.
Biodual, did you hear them talking earlier about the electrostatics in Cavendish? Now, you're going to do yours in a vacuum, but how are you going to discharge the electrostatics to where we can verify it?
Well, when I said reality, I meant the real
not
world.
For you.
The real
that was
Biodual. Don't worry. But yeah, I would not disagree that all 7 billion plus people live their own life and it's not mirrored to another life. And I'm a Glober.
Yeah, so the reality of every individual is the individual. That would be the reality.
Are you also saying the reality outside of each individual is unique, particularly the setting or the...
There is no outside reality. It's only based off the individual.
No. What I'm saying
without the individual, there's no reality.
What I'm saying is, I have a personal reality in which I interact from within my body and live my life and do particular things. You have that as well.
Based off the life that's been presented to you.
And we're
which
not
differs from everybody else.
And we're not living the same life. But if me and you go to the same location, do we perceive everything outside of our body the same? Do we see a sun in the same location? Do we see
no, we don't perceive it
in the same location?
The same way. We do not perceive it in the same way. You're a prime example of that.
No, not conclusions based on evidences, just the objective reality of, look, I point my finger and I can say that.
You believe that there's an outside world in which we all dwell in. Well, my argument is the individual dwells in its own reality. Nobody's reality is the same. That's the realm we live in.
And that's what I was trying to get at, is that, yes, we all have our personal lives that don't mirror someone else. And every day we all experience something unique to us. What I'm saying is, in the location and setting in which we do these things, are you saying that they are different?
Oh, I'm saying that we diverse from that as well. Meaning, you and I can be at the same store at the same time on the same date, and a shooting occurs. After the shooting happens, we make it out alive. We get home to our loved ones. We perceive what just took place differently.
That's not what I'm talking about. I think you're trying to be philosophical for the sake of being philosophical rather than being
Well,
objective.
philosophical is the realm we live in.
There's not. No,
That's my point.
It's not. We're not going to make any.
Yeah, it is.
I'll just end it.
You can't get away from it.
Well, let him finish.
There's no outside world in which we all live.
Biodual forfeits. James wins his first one-on-one.
No, there's no use in having an intellectual conversation with someone delusional. So that's fine. I'll end it there.
Wait there, no. That's not gonna go this way. I don't know your name, James. The guy who was just speaking, right? I didn't hear a word of what he said, and I know that. I think right. So it's all about philosophy, whatever. Cool. Let him finish his point first before, because like I think you both got something good to say. So let's hear both sides, these guys. Otherwise, it's painful for me.
I don't disagree with him as far as a personal experience, but as far as the location that we're doing it, like Kosha brought up earlier with like a GTA, it's a map. Everything is objective reality, but each character can have a unique experience. But it's still an objective reality outside of our bodies.
Right.
Yeah, I would agree with that, as in the terms that. No, I would, but the objective reality would be truth.
Well, objective reality, it's very difficult, isn't it? This whole thing of objectives.
Yeah, it would be absolute, like somebody from the outside looking in. I would agree with what he's saying. It would be an objective reality, but based off truth. This is what happened. Look, the outside looking in. Look at you clowns. Look at what you're doing right. I would agree with that. Yeah.
Right, guys, I'm gonna have to leave. Right. But it was great chatting to y'all. Could someone DM me the English time so when this shit goes down? Because I've enjoyed myself so far since being in here. Kosho, if you could DM me the English time so I can translate it.
Yeah, right. What time is it right now for you?
It is 3:45 a.m. I believe.
Right, I'll email you the time. I mean, the time's 10 o'clock for you. It'll be 10 o'clock. It starts at 10 o'clock for you.
What, 10 p.m.? Yeah. Oh, okay. So yeah, just DM me 10 p.m. Brandon. So just do something if you can.
I got you. So you remember. I got you.
Yeah, man.
Monday through Friday.
Monday through Friday, is it? Okay, so never on. All right, never on.
Yeah, Monday through Friday.
Monday through Friday, so never on Saturdays and Sundays. All right, sweet. Does that mean that he's like doesn't know when the Sabbath is?
Nice seeing you here.
Nice seeing you too,
No, I think
guys.
just with his family on the weekend. Yeah, it's
no,
always good to have people from the community join us here.
So, I've been here for ages. I just didn't know that anything
that's what I
ever
mean.
went on.
Like Arwen's been showing up, and a couple of Bob's been showing up. It's good when we have people that have been in the community for ages. All popping in and giving their ideas. It's fantastic. Yeah.
Yeah, definitely. It's good stuff. It's good stuff. Definitely, guys. All right, it was nice chatting to y'all. Anyway, right. Damn, Kosha, make sure you DM me anyway, because Kosha, you never do. You never DM me, bro. All right. I know I asked for a couple of things earlier and I didn't get them. I don't think.
Oh yeah. I'll DM you that paper too.
Yeah, please do, bro, because I don't want to be sat in obscurity. Like, if I'm wrong, I'm wrong, and that's that, right? But I can't debate these topics if you've got information that I haven't got. We're talking past one another. I'll personally unban you from 24/7 in a minute as well.
Sure, man. I'm not think I'm banned. I'm just not allowed in the main room.
No, but I mean, like,
in the live stream, yeah.
Yeah,
I
yeah.
appreciate it, man.
I'm looking into getting loads of people unbanned. All right now, so this will span lots and lots and lots of people. People just need to give me time to work on what I'm doing, and then you guys will be unbanned, right?
Fair enough.
Right.
I appreciate it, by the way.
It's all right. All right,
Yeah,
bless you.
I guess what I should have said earlier about the climate change, right? We could take every measure we could possibly take within the heliocentric worldview. A comet or asteroid, took out the dinosaurs, so they could, you took every measures you could possibly take, and then an asteroid wipes you out. Good for you.
Right. That's a good point, man.
So, does that mean we shouldn't do anything then? Because an asteroid might wipe us out. Is that your point there, James?
No, my point
Don't
is
do anything because an asteroid may wipe us out.
The scientists have dove into the world of philosophy and prophecy, and they're telling you the future, and you believe it.
No,
you heard it, guys.
I believe what I see is happening around me, James. What I see is happening around me is disgusting. That's what I believe. Nothing to do with asteroids or anything else. Heliocentric, flat, doesn't make any difference. What I see is reality and what happens. And in my environment around me and places I have lived, I've seen the devastation that we do where we live with no regret whatsoever.
Yeah, but if a person's going to come along and present a worldview that's fake, that most of the world believes, most of their life choices, the decisions they make in life, are based off the world they believe they're in.
Yeah, I disagree. But anyway, we'll agree to disagree.
Well then.
So you're saying that if you believed that you lived on an island with only so many bananas, you would eat as many bananas as you wanted, and you wouldn't base your life choices off the world you believed you was in?
What kind of questions are you asking, man?
They're very. I tried to make it basic for my argument. So it's a very basic question.
You're not making your argument very well. Me eating all the bananas on my island. Right?
If you believe, if there's much more land out there, but you're confined within a map.
It's not about eating bananas, James.
A worldview.
It's what we are doing to the environment.
It don't matter. What are you going to do to the environment's going to do to you what you do to it, right? Right? I mean, if you start a forest fire on purpose, that day in the news, they're going to broadcast the forest fire.
Okie dokie.
Yeah, so
what has me starting a forest fire got to do?
The only thing you can do to the
environment, right? What has it got to do with destroy the environment? Starting a forest fire, James.
Yeah, I'm just saying. I've flicked a few cigarette butts in my life, right? Like, there's no telling if I started one or not.
So what about all the animals that may have eaten those cigarette butts and then pass them onto their young? Or you're worried about a forest fire, but you're not worried about the devastation that it does to the animals or anything else. You're worried about a bloody forest fire. Really?
But why did I, because this was at a young age, I don't do that. I still smoke, but I literally come home with my pockets full of butts because I don't flip my cigarettes anymore. But I digress from that. My point is, right?
I'm away.
We do to the environment what happens.
I'm following.
So
I'm finding it hard to follow you,
if I flicked
James.
that cigarette butt out and I started a fire, I started the fire, whether I know of it or not.
Jesus Christ!
What's going on, Stacy? Hey, Stacy and Paige, I just wanted to let you guys know that.
So you don't.
Hold on,
still don't get what
I'm
I'm
gonna
saying.
let them know.
She's on Geffen.
Okay, well, never mind now. Well, Paige, still, we were. I know there was people at Gem Server who were interested in you going to ladies' night. So just let you know, we're going to do ladies' night every week, and maybe you'll be interested. It'll be Sunday morning for you when we do it next week, and also you'll have. It won't be. There'll be safe passage, is what Trish had said. Yeah.
Trish.
Well, you're more than welcome to come. She's a New Zealander.
Trish who?
She's from
Queen of Trolls.
I
didn't want to say her.
Will not be joining that server if she's there. Sorry, Dub, but I will not give content to any ball proponents. You know, I won't go on their channels. I won't join their Discords. I don't want to give them content. So, thanks, but no thanks.
Fair enough.
Wow.
I can't leave you guys like that. You guys don't know what I'm
Wow.
saying.
Why is that wow?
What I'm saying is when they chop the forest down.
I understand what you're saying. You're right.
No, about the cigarette butt. About the cigarette
If you thought somebody
let me
if you
clarify,
thought
please,
hang on,
for the
James.
audience.
Let Paige finish her thought.
There is no audience. No, now my
There's
thought's
always
gone.
an audience.
Yeah, if you knew a certain place was lying, you wouldn't go and spend your money there or help them in any way, would you? If you knew if in your heart you thought they were lying.
But Paige, do you really take the position that you're absolutely correct on everything?
Not on everything, no, but I am confident in my choice about this subject, yeah.
Okay.
So when they cut the forest, go ahead, Paige.
Can I just have one? Yeah, sorry, James.
No,
just while
you're
I've
good.
got a heap of you here, I was thinking with this whole free will thing, do you think it might be possible that when you create something with free will, because it hasn't been created before, you literally can't see what that thing's gonna do because it's never existed, because it's got free will? Do you think that might be like why things like, if the creator created Satan and all these things with free will, created us with free will, and bad things have happened, people say, well, why doesn't he just, fix everything? So I was thinking maybe it's more that when he creates something, he creates it, and only once it's created can he then see everything about it, because it now exists. Do you know what I mean?
No, I personally, I'm of the opinion.
In a sense, I think I know
the opinion that
Yeah, I got my brain all tied up thinking about that last night.
I'm of the mind that there's a cause and effect relationship to everything. Even these things that they say quantum stuff is random. I think if you have the output of any situation and you knew the knowledge of every single thing that situation, the main situation, that you could trace things back and you could see cause and effect relationship, and that true free will may not exist, but it may exist. I could be wrong, but that's
I couldn't think of a way that free will could exist if the creator already knows what you're going to do and everything that's going to happen before he even creates you. Why would he create? Like, why would you create Satan? You would just create another being to do his job that wasn't going to disobey or whatever. You know what I mean? But if he literally doesn't know what something is going to do because it's got free will, and he can't see their free will until the thing is actually created, then that kind of makes a bit more sense to me.
Yeah, yeah. It's hard, this kind of things. They're hard to come to
hard for our little brains to.
Yeah, but I mean, there's a lot of unknowns, and we'd have to make a lot of assumptions.
See, the thing I don't get is like medicine. They even claim that medicine is a field of practice, right? You'll have commercials saying
they're practicing medicine. Yeah,
if you've taken this pill, you could be highly compensated because the FDA allowed it, and now they're retracting it. So none of it in the first place was based off science. It's all based off of long-term effect. So everybody thinks today the vaccine for polio was a great thing, and in the future it could be, but if it had a long-term effect on our DNA, until you reached that long term, you would never see the effect.
What does this have to do with what Paige said?
My point is science, like it's not real science is the method, right? Because then you can get an empirical every time, all the time. So it's kind of off topic, but on topic. It's all based off the knowledge you're given. Like, it's all, you're the guinea pig. The knowledge is based off what you're given. So it's off her topic, but kind of on it.
Yeah, no, but let's try to stay on topic because it's more fun the conversation that way.
Yeah,
I like where Paige is going. Yeah.
Yeah, my neighbours have just started screaming at each other, so I probably won't come off mute for a little while.
No, that's not good.
Yeah, the whole reason a person will take a vaccine, right, is based off science. The comforting of science.
You know what science is to me, James? Somebody brought up the objective truth earlier, the objective reality. Science to me is a method to overcome the fact that even though there's an objective reality that I believe there is a true objective reality, objective truth, I think that none of us have access to the true perception of this reality because we all have our interpretations of what we're experiencing. They're coming through our eyes, and they're being processed by our thoughts, and so we all have everything has a different perspective of reality, and because of that, we need a method to come to some agreeance to what's happening. And so, even though me and you both have subjective perceptions of what's happening in reality, in order to approach the objective truth, we do things like science, which is basically asking a question and try to figure out.
No, we don't do things. That's not why we do. We only do science
for a natural phenomenon.
We only do science for profit. That's it. Whether it's physical money or the profit of heat, fire. Science is only for profit, and it's empirical, and that's the reason for it. You'll always get the same result.
Science is to answer questions that you don't have the answer to, like what made this thing do this, or how did this thing get here. That's what science is used for. It's used to figure out the answers to questions that we don't have access to before asking them. And you do science to come to some conclusion that can be agreed upon, whether I do it or whether you do it, and to actually isolate the answer. So you're going to
when we measure things that when we measure things within a certain medium, you and I will come to different results, right? But when we're surviving and we need a fire, whether or not we can start one we now know how to, like, you might have seen it on television, different than reality, I agree. But you know how to start one in the wild for survival. But that don't mean you can start one, right?
Jay, do you drink at all?
That's my point. So science is like totally empirical,
you don't.
based off survival.
If you had two fires and said to somebody, tell me how these fires were made, you know, one could be made by rubbing sticks together, one could be made by using a magnifying glass and setting it on fire.
Or a lighter.
You know, the things, our side of the argument is just trying to say to the ball, look, we've all got the same phenomenon. We're all using, you know, the same earth to make our observations. We've just got a different explanation for some things. And I'm finding it really frustrating that even things that don't affect the shape of the ground, like, you know, like maybe cold moonlight, things like that. You guys won't even entertain that anything could be wrong in that heliocentric model. And it's really sad because, you know, cold moonlight, it's been shown, it's been tested, you know, these things, and there's no point just ignoring these things because you're worried that, you know, your ball might be shown wrong.
I think that's unfair, though, Paige,
if
because
you could be wrong in the medicine of science.
Hold on, James. I think that's unfair, though. Hold on, James. James, hold on, man. I think that's unfair, though, because that's not entirely true. That everybody can't agree or can't fathom that anything in the you know, whatever you want to call it, heliocentric model is wrong, or an our idea of science is wrong.
Fair enough. I should have said most of you.
Sure, yeah. There's a lot of people who don't even think about it, and then there's also a small amount of people who think about it a lot and don't entertain those ideas. But if an idea like the cold moonlight, when I first heard about it, I thought it was an interesting thing to test. And it certainly is when you first hear about it. I don't want to. I mean, we don't have to get into an argument about cold moonlight. But regardless, yeah, when hearing things like that, it certainly is interesting to look into. Just if it's true, it's true. If it's not true, it's not true. Yeah.
We got a full moon out tonight,
and
I got a
if it's true, it's true. If it's not, it's not. But people get their knickers in such a knot over, you know, a different explanation. It's like, well, can't we just check first before you get all angry and twisted?
This whole community we should be putting all our time, money, and effort into proving if there's drop or not drop from horizontal. That's all that matters.
Yeah, we should be encouraging people like Travis and.
No. He's saying that, knowing that that's dude. I put up that thing where I was asking people to participate in my test, to participate and donate, because it's going to cost a couple $100, and I've already made the purchase, I'm just waiting for it, but I'm still, you know, I'm still taking donations, of course. But regardless, that's exactly what our test is doing, Jeremy. You know this, man.
You're using GPS though.
GPS works
to make your horizontal.
GPS works, man. Give me an example of GPS not working.
Nah, you've got to do everything really strictly. Like, don't use any of those kinds of things.
Why not?
I can give you an example of the first GPS by the United States military, which was ground positioning system based off triangulation.
The thing is, that's not in any way relevant. That's not in any way helping anybody's argument in this one, man. We understand that. That's not what's the question.
You say GPS based off global.
Is the information it gives you useful? That's what we're saying.
All your towers are on the ground.
Okay, fine, then they are. You're right. I agree with you. That's what they are. But it doesn't matter. The question is, can you trust the information it gives you?
That's the only thing that matters. If you didn't have to have ground towers, I would believe there's satellite communication within space.
I agree with your point, man. Can we but anyhow, what the fuck? Yeah, this is a test that I'm doing, is using GPS to define reference points, which we agree it can accurately give you. And it accurately gives you reference points, which you can use to measure this straight line. You can actually do this with a GPS that I'm not getting. If you didn't mind getting it slightly wrong, because there would be an error margin, but the one that I'm getting is going to be accurate within a centimeter. So you can measure points on the Earth and get it right up to a centimeter accuracy.
In 3D space.
The Earth is in 3D space, exactly. So you can use it.
And this will give you accuracy up to a centimeter, anywhere, left, right, up, any axis, within a centimeter.
Yeah. GPS gives you coordinates based in longitude and latitude, which are angles, and elevation, which is a distance.
It's just
it does this because those are spherical coordinates. And even if you disagreed with that fact, they're still coordinates. And those coordinates are transferred from those three to the regular three that you're used to.
Those are not spherical
which are just three location, which are just three. Hold on, man.
They're circle coordinates.
Hold on, man.
Which are just curved.
Hold on, man. Dude, there's no point in interrupting right in the middle of like that. I start over. Yeah, the three coordinates is two angles and a distance. It transfers that from three coordinates in the way in which you're probably familiar with, which is 3 points. Hold on, 3 points, X, Y, and Z. Okay, so what you can take the raw data, which will be in X, Y, and Z, and it will already be in 3D space.
So before we do this, we'd be able to go up, down in a building. I could climb a ladder, go down, and it would all give me all the correct elevation.
Yeah, you're on the right track, Jeremy, because that's exactly what I plan to do before I even do any measurements. Is I'm going to test the validity of it by measuring the four corners at the base of a building, the four corners of the top of a building, and seeing if this makes indeed a rectangular shape, like a rectangular prism, just like a building. So that would test the validity of it. If this works works accurately, then it'll indeed be able to be used to make straight lines anywhere.
Is there any other way we could verify that we are making indeed a straight line?
Yeah, you can measure any.
I hate to do it just off of that.
Yeah, well, you can. You'd have to think of something else that is relatively straight, that long enough that you could just make sure it's still giving you a straight line there. Yeah, I mean, it would be a good example. I don't know.
So I mean, I'd like to have something else. Even with my method, the methods I was using, I still wasn't comfortable with just using one method. I always wanted to do a second and a third one, even if there was.
Okay, well, here's another thing you could do. You could go to, again, a very tall building, measure it at the top, and then let it down with like a string. I can probably go 1,000 feet, the 1,000-foot string, and measure it down there and make sure it's a straight line. Like there's different. You can just measure
What do you think about the double rotting method Bev brought up?
I think his test is ridiculously stupid, and I think he's never going to do it. And I think that
the double rotting method wasn't even in his test. I don't know.
Yeah, I know exactly. You brought it up though. You brought it up, and I think that's a good idea. But the thing about using the GPS is it eliminates all we're going to do is debate about refraction and lasers being refracted and all this other type of stuff. When you have using light as in visual optics and stuff like that. Whereas this eliminates that entire problem. You're never gonna have to worry about,
I know. I'd still like to have some other way at your location with the GPS thing to make sure that it is indeed a straight line.
A building wouldn't do it. Measuring the 8 corners in a building.
Oh, you guys say the buildings are the foundation. Well, I don't know.
The only distance you have to record that has to be verified, right, is the road.
I feel like you're not even sure. I feel like you have no idea what we're talking about.
Kosho.
You can't look at a flat map, right, and draw a straight line from Colorado to Florida.
Okay.
And determine that
it's not straight, but let's see what
it's 2,000 miles.
Sorry, you just reminded me when you were talking about surveying. It just reminded me that the guy who does the infrared long distance photography took
Jay Tolan.
That's him. Took his auto level, or I don't even know what it was, whether it was a theodolite or an auto level, but he took it out to the aqueduct in California, and measured how he thought he'd measured the globe and was like, couldn't believe that it matched the globe perfectly. But then he noticed that the water, even though the aqueduct itself was like changing from horizontal, the water was in some places lower down on the concrete. So he actually had to go back and measure like from the top of the concrete down to the water. And in some places there was like 6 feet, and in other places it was really close to the top, showing that the water wasn't following this curve that they'd put in the aqueduct, because they'd made it, supposedly made the thing to curve around the earth. But the water doesn't seem to give a shit what they made it do, because it's not following the curve. So you might be interested to watch it. I'll go and grab it for you.
I've seen his video. I didn't watch the whole thing. I've seen most of it,
newest one?
No, yeah.
It only came out like yesterday or the day before.
No, I haven't seen it.
Yeah, no, this is different to the one that he did like ages ago, years ago, whenever it was. This is a new one. He went back to the same spot, I think, if I remember rightly. Last time he was at the same aqueduct, but this time he's done more, more measurements, and yeah, it was quite interesting.
I'd certainly be
interested. Yeah, but what I'm saying is all they have to do is give you accurate measurements, depending on where you live, miles, kilometers. They only have to give you accurate measurements of the road, and at that point, you're confined to the map.
James, I'll give you $1 if you tell me what we're talking about.
Like you're literally, if you draw a straight line from Colorado to Florida on the map and it's 2,000 miles, obviously you're going to travel 2,500 to 3,000 miles because of the left and right. But as long as they give you an accurate measurement of the road, you're confined to the map.
What does that got to do with what Kosho's talking about?
Well, he was talking about the measurements of the earth.
He was talking about he was checking the accuracy of GPS by mapping out the shape of a building.
Yeah, but the GPS is based off what?
It's not. I don't. What do you mean?
Listen, James. The GPS I'm talking about is not ordinary GPS. There you go, Coach. Oh, thank you. I'll definitely check this one out. Hopefully it's not too long. But the GPS I'm talking about is called the GPS.
It is a bit long, sorry, but
his other one was long.
I listened to it at like 1.5 just to get through it a bit quicker.
Global positioning system.
Yeah, I know, that's fine. Well, let's just call it ground positioning towers, okay? What I'm using is using that system.
I was talking about.
I know exactly. I know that system I'm using that. But it's a special device that you attach to like a small computer thing, and it'll give you centimeter accuracy positioning. So you'll be able to get a position just like GPS gives you, but it'll be precise enough to be accurate up to a centimeter away from what you're measuring. Okay, that's what I'm talking about, James. I'm not sure if you were aware of that, but
based off the map.
Yeah, I was thinking about it. No, not based on maps in any way whatsoever. But
based off the map.
No, not at all based on maps.
You verify it.
No, but
so what's the
highways.
Point of it?
But highways, because when Eisenhower had invented the interstates, he made every 5 miles there had to be 1 mile that was completely straight. This is for every interstate in the country.
1 mile of what? The map? 1 mile of what?
The road, James.
Said the interstate, man.
The map.
Yeah, the mile-long map.
What are you? Road.
Yeah,
the road.
The map.
No, the road.
Yeah, the map. The map.
I was interested, Kosho. What were you saying about the 1 mile every 5?
No, I was thinking that I could test it on a building But it's possible that I could also test it on that interstate. Yeah. Jesus. Like you have maybe it's you that has echo germ. Somebody had this, but either way, yeah, on the interstate you could test it. Yeah, to make sure that it's actually making a straight line. I think though, if, a mile long interstate, you will not get a straight line if the Earth's curving. Though you'll actually be able to see that 8 inches. So that'll probably be a good test to see the deviation. But I'll probably want to do, more conclusive tests than just 1 mile. Actually, a good idea just to, like for a proof of concept. Yeah. Whichever would that make you think a little bit if I did a mile long? Well, no, that's not even really, because the interstate could be 8 inches.
Proof.
It's
there you go, Kosho. Proof of concept. I can give you a proof of concept of the entire flat Earth. Water, dirt, lights. Why doesn't that sway you at all?
Oh, I mean, just B-Baller for Life just posted a proof of concept of an idea of flat Earth. If you had a kind of model of the flat Earth, I mean that'd be awesome to see. But with a model, though.
No, I mean a real life, something that you can actually hold in your hand that's got water and dirt and sunlight, air pressure, everything. Could you honestly tell me you could do the same for me?
No, I couldn't.
For your model,
I could not do the same.
So does that not sway you at all?
Well, I would have to see the model and test other things on it other than the fact that it had water on it. I have to test.
No, I understand that, but that's not what this proof of concept is for. We can go into the math and everything later, but when you start at the beginning, you've got to show that these things can actually physically exist. So you need to show that water can physically curve, in large quantities around a ball, and show us, in reality, like we can for you. We can bring you a proof of concept and say, okay, let's start from here, But you guys want to always work backwards. And we're just sort of saying, well, can we go back to the beginning? Let's look at this from...
Not really the beginning,
from the start.
But let's work with what we have.
Or, work with what we can... what meager things us peasants can get our hands on. If we had $56 million a day, sure, we could do heaps of shit for you. There's so many tests people want to do, and we just don't have the money. All that's stopping most people is money.
Yeah, if a government nation...
We can't even go and get a grant from the government or something, because we're not allowed to be talking about this. So it's not like we're ever going to be able to, like create a school and start getting government grants and shit.
Well, I'm just saying that if a government nation or empire...
man. I'm curious, what did you mean by, what did you mean we weren't allowed to be talking about this?
Let me tell you what she was saying.
They don't particularly want to talk about this, do they?
If a government, nation, or empire is in control of the skies, meaning
he doesn't.
You have to get their, meaning you have to get their permission to enter the skies, right? The chances are
like
they're lying to you about what they are. They don't want you to have superior military force of the skies, right?
James, I agree.
Why would they tell you what they are?
No, go ahead, James. James, I'm just gonna have to turn you down a little bit now because I want to hear what Paige has to say, and you won't give her a chance. So, but what did I say? Oh yeah, what do you mean we're not allowed to talk about this?
Maybe I shouldn't have said we're not allowed to talk about it. We're programmed to have a certain response to this topic, and
okay, I understand.
the fact that we can start with something tangible, something we can sit on our lap and go, yep, okay, water, yep, mountains, yep, okay, ceiling, yep, that means air can stay in there, and we can stick lights on the ceiling, yep. You know, at least we've got a foundation, a reason for us to think the way we think. But if we were to put you in that position, you wouldn't be able to take that first step to even justify why you even think